Hello and welcome, I'm your Kodmaki, and welcome to my free simple multiplayer course. Here let's make a simple multiplayer game from scratch. We're going to make a nice tic-tac-toe game. It's very basic in terms of game design, which means this is a great learning project. It means we can focus on the implementation of the multiplayer itself. By fully learning everything in this course, you will then be able to make multiplayer games of all kinds. Games like Among Us, Phasmohpobia, Stardew Valley, Minecraft, Lethal Company, Valheim, Overcooked, and many more. Despite tic-tac-toe being quite basic, despite that, it still requires us to learn the basics of multiplayer game development, and all those basics are shared across all of these games. Once you understand those core basics, once you understand that, you can definitely expand upon it to make all kinds of multiplayer games. Here we're going to have a multiplayer connection between two clients, one of them being the host. Then each player is going to take turns to do their action. The data is synchronized towards the other player, and once there's either a tie or win, the game ends and we can start again. So yep, this game is super simple, but it still requires us to learn a ton of things. And then, like I said, you can expand upon this after you know the basics. Multiplayer games are really just all about synchronizing data. So once you know how to synchronize data for a simple game like this, you can definitely sync more complex data. Now, this is a beginner multiplayer tutorial, but multiplayer isn't exactly for absolute beginners. So if you are an absolute beginner, if you've never touched Unity or C# or made any games at all, if so, then I highly recommend you start with my free beginner courses. You can learn the language itself in my massive C# course. That one takes you all the way from absolute beginner to advanced. Or if you prefer a more practical approach, for that you can follow my free course on making Kitchen Chaos. This is a really interesting game that makes for a great beginner starting point. That one also has a follow-up course on making that game into multiplayer. So either of those two are a great starting point if you are an absolute beginner, but if you already know the basics of Unity and C#, like what is a mono behavior, what is a game object, how does a game object get instantiated, what exactly is a Unity component, and so on. If you know what are functions and how classes can interact with one another, if you know what are C# events and so on, if you know all those basics, then you should be able to follow everything in this course. Thanks to the awesome tools that exist nowadays, making multiplayer games isn't really all that difficult. So here we're basically going to put that to the test. Let's see how easy it is to make a very simple multiplayer game. And as always here, let's write proper, good, clean code. We don't want to write quick and dirty prototype code. Despite this being a small project, I will be teaching you how to write good, proper production quality code. Also, just a quick note, Unity currently has two netcode toolstacks. There's netcode for game objects, that's the one we're going to use in this course. It's their toolstack for generally small-scale co-op games, so things like Overcooked or Among Us or Phasmohpobia. It's also their simplest toolstack. And then the other one they have is netcode for entities. This one is more meant for super fast-paced competitive multiplayer games, or games that require lots of sync data. So for example, games like Call of Duty, for that, netcode for entities would be the best tool. But it is quite a bit more complex, especially since it works on top of dots. Dots is relatively complex, it's Unity's toolstack that is insanely performant, but slightly complex, so definitely not for beginners. I have a 1-hour video going over how netcode for entities works, if you want to see that. And I'm actually currently writing basically exactly the same course, but making it with netcode for entities as opposed to netcode for game objects. I'm really curious to see that. I really want to experiment with basically the differences between the two toolstacks. So making the exact same game with both toolstacks should be quite interesting. Like I said, I'm currently writing that course right now, so stay tuned for that, or if you're watching this in the future, check the link in the description. Okay, so let's take a quick look at the final game we're going to build. So here it is. In the game we're going to implement lobby. This is how we can have our players find each other. So players can create lobbies and other players can join them. So over here we can create on this one. I've got two windows open so we can easily test the connection. So that one created a lobby, then this one down here I'm going to refresh the list and I'm going to join this lobby. And as soon as I do, this one is going to see that we have two players join and is going to start the game. So I join this one, and that one joins, and if there you go, we have a connection being established. And in the background, the connection is being established through Relay. This is one of Unity's services that helps you bypass firewalls and bypass NAT. This way it ensures that your players can always connect with each other, so you have no issues with connections. And then yep, here we are in the game. So in the background we can see some music playing. So the game has music and sound effects. Then we can see we have our nice board with our nice 9 grid positions. Then up top, the nice UI, so it is showing the current score for each player, and it is showing the two possible players, so the crosses and circles. We can see an indicator, so we can see this window over here, this one is playing as crosses, whereas this one down here, this one is playing as circles. So right away, we can already see a bunch of multiplayer things. So first of all, we have a connection being established, and then secondly, we are synchronizing some data so that each player knows who they are. Then we are also synchronizing who is the current player, so for example, down here, these circles cannot currently play. We can see some arrows over here. These arrows indicate who is the current player that should be playing. So right now it's the crosses, so if down here on the circles I try to click, nope, obviously it doesn't work. It is the crosses over here that has to play, so over here I can select any of these 9 positions, just go ahead and click, and if there you go, that spawns an object. The object is spawned, and of course the whole thing is synchronized across the network. So the object was spawned here, but this client also sees the object. Now it's this one, so once again the current playable player type, that one was also synchronized. So now it's the circles. So on this one I'm now going to take a move, and there you go, plays on this one and also over here. So both the client and server, or rather the host, both of them are currently synchronized. Now on this one I can take another move, then on this one another move, and on this one I take another move. And when I do, it's going to make 3 in a row, so as I do it, yep, there you go, I have a nice win. So the game correctly identified 3 matching symbols, and yep, there's a win over here, and this one of course, this one lost. So that's some more data being synchronized. This one knows that it won, this one knows that it lost based on which player is currently controlling it. And up here we can also see the score that updates, so crosses currently has 1 score, and down here the circles has 0. So yep, then we have a nice rematch button that is going to reset the entire board, and now we can start playing again. We can do all kinds of things, and when you do, yep, there you go, we play again, 1-1, rematch, and so on. Here you can see all of the various multiplayer things that we're going to do. We're going to handle the connection, we're going to handle synchronizing transforms, we're going to synchronize object spawning, synchronize network variables for the score data, for who is currently controlling what. We're going to learn how to minimize bandwidth, how to spawn or not spawn some things, and so on. So yep, despite the fact that this is a simple game, it still covers lots of things. So that's why I say, if you learn how to make this game, if so, you will have the base knowledge required to make pretty much any kind of multiplayer game. Now, there are project files and assets downloadable from the links in the description. Those are all completely for free. And also, there is a premium version of this course. Although there's no knowledge and no project files behind the paywall, all of that is completely free. You don't have to pay 1 cent to learn all this knowledge. But if you can't afford it, if you do have a few bucks to spare, then the premium version actually has some really nice bonuses. First off, obviously it has no YouTube ads, so there's nothing to interrupt your learning process. Then it also grants you access to my private Discord and private live streams. I do those every week and I'm there to answer whatever questions you have. Then the premium version also has priority QA, meaning I won't be answering questions on that version first, but I will still be answering comments over here on this free YouTube video. The premium version also has a really nice companion project. This one contains quizzes and frequently asked questions for each lecture in the course. The goal with these is to really reinforce everything you're learning. If you make the effort to pay attention to every single lecture, if so, you should be able to get all of these correctly. And if you do, then you can be sure that you are truly learning. If you take the time to go through all of these, almost 150 of each, if so, you will gain all this knowledge. The next bonus is the CodeMonkey Companion. This is a Unity window that keeps track of your project, it analyzes everything, and if you encounter any errors, it will hopefully help point you in the right direction. Another nice window is Chat with AI. Like the name implies, this lets you chat with an AI that was trained on the contents of the course. It's a great way to get some help pretty much instantly so you never get stuck. Or alternatively, when you post in the course comment section, you will get a near instant reply also from this AI. This is also really great for getting some quick help, but again, I will manually answer within the next 24 hours. So yep, these are the bonuses for the premium version. If you can't afford it, that's awesome. You get some really nice bonuses to help you truly learn, and if just a tiny percentage of the people watching this video pick up the premium version, if so, then I can keep on making free courses. So if you can't afford it, that's awesome, thank you, and I hope you learn a lot. But if you can't afford it, then that's fine. All the knowledge is completely free right here in this free YouTube video. You really just need to put in more effort to guide yourself and apply what you're learning, as opposed to just following the path that I have pre-prepared for you in the premium version. Here I just ask you to go ahead, like this video and subscribe to the channel. It's a small thing, but it really does help. Alright, so that's the intro out of the way. Now let's go on to the next lecture where we're going to see a nice overview of everything we're going to do throughout this course, everything from completely scratch starting a new project, until the final polished game. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to see a quick overview of all the lectures and everything we're going to learn in this course. Okay, so we're going to start completely from scratch. On the very first lecture, we're going to create a completely brand new empty project. Then we're going to install the packages that we're going to use, mainly netcode for game objects. And we're also going to very quickly see how we can create a connection between 2 clients in literally seconds. That's how easy the tool is to use. Also in this lecture, we're going to import all the visual assets we're going to use in this course. Then we're going to set up the grid, place all the visual objects, and define the grid positions. We're also going to explore multiple methods for handling how to capture clicks on each grid position. After that, we build the main GameManager script. This is going to be the class that will handle the core logic for our game. Since this class only has a single instance, here we're also going to learn about the super useful Singleton pattern. This will make so many things in the rest of our game much easier. Next, we're going to create a game visual manager. This is a separate script that we're going to build to intentionally separate the main game logic from the visuals. Like I mentioned, in this course I am teaching you how to write good clean code and not quick and dirty code. So to do things properly, we are going to decouple the visuals from the underlying logic. Here we also learn how to spawn objects, first by doing it locally and then by spawning them on the network. And we're also going to learn about one very crucial thing about multiplayer, how the server is the only one that can spawn objects, how the server is the ultimate source of truth. On the next lecture, we're going to solve that problem by using RPCs. These are remote procedure calls. Basically, it's how we can send a message from the client to the server to tell the server to run some function. This is how we're going to have the client be able to tell the server to spawn some kind of object. In the next lecture, we're going to fix one issue we see when spawning, how the position is not synchronized. To solve this, we're going to learn about the very useful network transform component. Once again, this is another example of just how easy the tools are nowadays. We just had this component and that's it. Our object's transform is automatically synchronized. Next, we implement the concept of a player type, either a cross or a circle. We define an enum to define the actual type, and then use the network client ID to make the server play crosses and the client play circles. Then we're going to set up a nice player UI. This will have a visual indicator as to which symbol the local player is playing, as well as the current active playable player. Then on that previous lecture, we will have an issue with synchronizing some data. So to solve that, we're going to learn about another super useful netcode for game objects feature, the network variable. This allows you to automatically synchronize some data without needing RPCs. After that, we create a network manager UI, just a simple UI with buttons to either start host or start client. Next, we're going to create the player type array. This is the 2D array that will store the state of each grid position in our game. With this, we will ensure only one player can take an action on the same grid position. Then for some game design logic, we are going to implement a test-winner function. This one just checks if we have 3 matching player symbols in a row. If so, then yep, we have a winner. We check all horizontal lines, vertical, and diagonals. After that, we make a game over UI. This is what we show when someone wins a game. It will either say you win or you lose on each line. Next, a super simple one, just adding a rematch button. This is quite easy to implement. We really just destroy all the visuals and reset the board state. After that, we implement the other possible end condition. The game can also end in a tie. This is also quite simple to identify. We just check the entire board, and if every position is occupied and we have no winner, if so, then it's a tie. Next, we add a persistence score to keep track of all the wins and losses for each player. This one also uses a nice network variable to keep that data synchronized. Then for something fun, we implement some sound effects and music to make the game come alive. After that, we implement 2 very important multiplayer tools, Lobby and Relay. Lobby is how we can group our players together before starting the game, and Relay is a super useful tool that helps us bypass firewalls and nets so our players can host and actually connect to one another. Then we have the polish stage. So here, just adding a ton of tiny things to make the game really come alive. And finally, we will look at the final polished game. So yep, throughout this course, we will start completely from scratch and step by step build this really nice game. The game design is very simple, which makes it perfect for us to focus specifically more on the multiplayer implementation. Which, like I said, thanks to the awesome tools that exist nowadays, this game will be actually pretty easy to make. So yep, let's get started and create a completely empty new project in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to get started making our project. We're going to set up Unity and install all the packages. Alright, so let's start completely from scratch. So let's begin by creating the project. Over here, I'm using Unity 6, so it's this version. We're going to be using the universal 2D template, so we're going to be using URP. Let's just give it a name, Tic-Tac-Toe multiplayer. And let's create the new project. Alright, so yep, here we have a nice empty Unity window. Now, in order to make multiplayer games, we are going to be using Netcode for game objects. This is Unity's networking toolstack. So on the package manager, over here on the left side, let's go on the Unity registry. Then scroll down to find the netcode for game objects. Yep, here it is. This is the version that I won't be using, 2.1.1. Now, if you're following along, I highly recommend you use the exact same version as me. If you use a different version, the syntax might be slightly different. Although both Unity 6 and Netcode for game objects, both of those are already very robust, so I'm guessing that even a few years from now, this tutorial will still be very much up to date. You can also download the starting project files from this lecture. I've included a brand new empty project with just the packages installed and the visual assets. So if you start from those project files, you are guaranteed to be using the exact same version as me. So yep, here I'm going to install this package. Alright, so the package is installed. Now we can begin making our simple tic-tac-toe game. Although first, let's actually handle our multiplayer connection before we even build any kind of logic. Let's do that first, just to see how easy it is. So over here, let's actually first just rename the scene. Instead of sample scene, name this the game scene, okay? And now let's go ahead and create a completely empty game object. Name this the network manager. And over here, let's add a component and let's search for a network manager. Yep, this component right here. This is the main component inside Netcode for game objects. This is basically what handles starting the connection, handling the underlying data. It has all of these various settings and so on. Now, the first super important thing we need to do is choose a transport. So over here on network transport, we need to have something assigned. The transport is what actually connects and sends bytes across the network. Basically, the network manager, or rather Netcode for game objects, is a layer on top of the transport. And over here, we can click and we can select from a various amounts of transports. By default, we can just pick the Unity transport. So if we click on this, yep, there you go, it adds this one down here. It has a bunch of settings, but we can leave those all as just the defaults. Now, the reason why the transport is selectable, the reason is intentionally to allow you to use any transport you want while still using netcode for game objects on top of that. So the whole thing is intentionally modular. For example, if you want to use Steam servers, meaning use their relay, their lobby, and so on, if you want that, you can just replace the Unity transport and use the Steam transport, and then basically use the exact same netcode for game objects on top of that. So basically, the actual code for your game does not have to change. You can easily swap in and out a different transport and everything will work fine. But like I said, the simplest thing is Unity transport, so let's use exactly that one. And yep, just like this, just in a few seconds, we already have the basics working. If we hit on play right now, and now we look at the network manager, which by the way, as soon as you hit on play, we can see over here on the scene view, the network manager is no longer on the main scene, it is actually over here on the don't destroy unload. That is because this object persists throughout scenes. So if you can't find it on the game scene, make sure you look inside of this scene. So yep, over here, if we look in the inspector, now we can see, yep, we have these nice 3 buttons. Right now, the game is completely offline, so right now there's no connection, and it is not listening to any connections. Here we can choose 3 options. We can choose to start a host, a server, or a client. Now as to what all those things mean, those are basically different network topologies. So in netcode for game objects, you can basically set it up one of 3 ways. You can have a dedicated game server, or you can have a client hosted and listen server, or you can have distributed authority. So on those options, when you create a server, that is literally just creating a server and nothing else, meaning there is no player controlling it, it is just a straight up dedicated server and nothing else. Then for the client, that is what all the clients use, what all the remaining players. So it's basically what they use to connect to the server and play. And then we have the host, and the host is basically a mixture between a client and a server. So the host hosts the server itself, the server that other clients can connect to, but then the host also has a client, so the host can play locally. So the host can control a player and is running a server. Now, if you want your game to be using dedicated servers, then you would make a server build for your server and then make a client build for each of your players. Whereas if you want your game to be player hosted, like most co-op games, then one player would be the host, and all the other players, those would be normal clients. This is the simplest network topology, so it's what we're getting. And thirdly, like I said, there's also distributed authority. This is a bit of a more advanced thing. This basically is a mixture so we can have essentially multiple hosts instead of just one. That way different clients can kind of act like hosts on different parts of the world and have authority over different objects. Like I said, this is a bit of a more advanced one, so we're not going to focus on this. For this game, we're going to be using the simplest network topology, which is going to be this one, the client, hosted, and listen server. We're going to have a host and then various clients. So yep, here inside Unity, let's just go ahead and click on Start Host. And yep, that's it. Now we have a connection started. Except we don't really see anything happen. Nothing is moving, nothing is changing, so let's actually connect a client. And for that, we're basically going to need a second window. So one way to have a second window that we can use to connect to, one way is just to make a build. So we could stop playing, go into File, Build and Run, and create a separate build. Basically, we can create an executable, and then we can run that executable. We can have the main Unity window be the host, and then have a second executable that we run and use that one as a client. However, using this option, making a build, that actually takes quite a bit of time, so that process is quite slow for multiplayer development. As usual, when making any kind of game, iteration is always something you want to be as fast as possible. If it takes 5 minutes to make a build every time you want to test something, that is really not very nice. That is going to drag you down very much. So thankfully, Unity has recently made a really awesome package to help solve exactly that problem. Let's go into Window, into the Package Manager, and over here, once again on the Unity registry, let's go down and find this one, the multiplayer play mode. This one, like it says here, this is a feature that enables multiple editor instances to be opened simultaneously on the same development device. This is a really awesome thing, so let's go ahead and install it. Again, here's the version I'm using, 1.3.3, but again, if you import the project file from this link, you will have the project with all the packages installed. So yep, let's go ahead. Alright, it's installed, so we can close this, and now we can go up here into Window, then go into Multiplayer, and yep, over here we do see the multiplayer play mode. Here it is essentially a separate Unity window. We can actually dock this, so let's grab it over here from this one, and let's put it down here. Yep, there it is, there's our multiplayer play mode. And over here, this is really powerful, but also super simple to use. We'll literally just have these checkboxes. Basically, as soon as we click, and of course, make sure to save changes. When we do, yep, there you go, look at that, activating. So right now, it is basically spawning a brand new Unity instance in the background. So let's wait for it to spawn. And yep, here it is. Here we have a second window. It literally is essentially a separate Unity window. And now if we hit on play over here on the main Unity window, when we do, yep, look at this one. This one is also importing assets, also hitting on play. So if there it is, now we have two separate windows, each of them is currently running. Then over here on this one, here we have a nice layout button, and we can add a bunch of default windows. So in this case, let's show the hierarchy and the inspector window. And if they're this, so now we see exactly those. So again, this is pretty much a second Unity window. Now inside we can inspect the hierarchy, so over here we can select Network Manager. And up here we have the inspector and we have access to those nice buttons. So now over here on the main window, let's select Network Manager, and on this one, let's start a host. Yep, there you go, this one is now a host. And on this one, we can start a client. And if it is, this one is now running, and we do have a connection currently going between these two windows. All right, awesome. So yep, you can see just how awesome this little package is. You can create up to 3 separate windows. So if you want to quickly test a co-op game with up to 4 players, if so, you can just spawn 4 windows and connect them all directly. So this really saves you a ton of time. Basically, if you modify the code at all, it really just compiles over here on the main window, and then it just copies those changes onto all the other windows. So instead of spending like 2 to 5 minutes building a separate build, instead of that, it just compiles your code changes in something like 10 seconds. Then you can easily press on play and all of those play, so it really makes multiplayer iteration much faster. This really is an awesome package. I'm really happy that Unity built this. Okay, so yep, like I said, over here we started the host, and over here we started the client, meaning we have a multiplayer connection that is currently running, except it doesn't really look like it at all. We haven't really synchronized any data just yet. So in order to verify, let's actually install another very useful package. So let's go once again, open up the package manager, and then over here, yep, we have this one, the multiplayer tools package. Let's go ahead and install this one. This one also has a bunch of various helper tools. You can check documentation if you want to see details on all of these tools. You can just go onto the Unity multiplayer docs, and over here go under multiplayer tools. Also, by the way, quick note, if you try to install a package whilst a second player is running, if so, it's going to crash and need to restart. Alright, so yep, so we installed that package. And now let's use one of those tools, a very simple tool, just to verify the connection is working. Let's make a new empty game object called the runtime network stats monitor. And over here, let's add a component with the exact same name, the runtime network stats monitor. So if that's it, and nothing shows up, that makes sense, that's correct. It only shows up when we hit on play. So let's do that, let's hit on play. And once again, both windows are currently going to be playing. By the way, make sure you save the game scene before hitting on play. And okay, yep, now we do see this nice little window. So we have our hierarchies, all of them correct. Again, if you're not seeing this object over here, make sure you save the scene before you hit on play. So yep, we have this nice one, and right now we can see no data received, so yep, there's no connection. Now select the network manager, and let's go down, this one start the host. And if there it is, and we can see the runtime trip to the server is at 0 seconds, because this one is the server, so there's no time. And then over here down there on this one, let's go on the network manager, and scroll down, start a client. And if there it is, now we have the round trip time, and we can see, yep, we are indeed sending a bunch of bytes across the network. So yep, here we have this nice graph showing us the connection. So we can indeed verify we do have an active connection. All right, awesome. So yep, right away here you can see just how simple it is to start a connection. We really just create the network manager, we assign the network transport, then we start a host on one side, start a client on the other side, and yep, that's it. We have a completely nice multiplayer connection. So yep, that's awesome. But of course, we just have a connection right now. We really have no custom data being synchronized. So let's do that in the next lecture. But before that, let's import the visual assets we're going to use in this course. There's a download link in this lecture. It's a zip file, and inside contains this nice Unity package. So on this one, just drag it and drop it inside Unity. And up here, there's the contents of the package. So we just have a bunch of sounds and a whole bunch of nice images. So yep, select everything and let's import. And yep, here are all our textures and all our sounds. Now is the time to go ahead and download the project files for this lecture. That contains a zip containing the entire project files. So when you open it, you will get exactly this. You just unzip the entire project onto a folder, then open up your Unity Hub, and up here go into add a project from disk, and go towards that folder. Also, secondly, on the lecture downloads, you can also see these two files, a VS4 file and a Visual Studio settings file. These have to do naturally with Visual Studio. These are technically not required, it's just if you want to make sure that your Visual Studio looks exactly the same as mine. Over here I'm using Visual Studio 2022, it's the free community edition. To import those settings, you can go into Tools, then go into Import and Export Settings. And if over here, just follow the import, select that file and import it. Make sure you do a backup with your own settings in case you want to go back to those. And secondly, the other tool is called VS4. So for that, you can go into Extensions, manage the extensions, then look for VS4 and you can find this one. This one, basically just a simple extension that adds a bunch of colors on the code. Personally, I really like this, but again, this is completely optional, so if you don't want it, you don't need it. But if you do want it, then go ahead and install. Then go into Tools, Options, scroll down until you find VS4, then go into Export Import, and again, same thing, import settings and import that file. So once you do all that, once you start from this project, once you import the Visual Studio settings and the extension settings, once you do all that, you will see everything exactly the same as I have here in this video. That will make it very, very easy to follow everything in this course. That way everything will look exactly the same. There won't be menus in different places or different names. Everything looks the same, so it makes it much, much easier to continue going through this course. So yep, go ahead, grab those, set it up, and let's keep going on to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to install the companion project and go through it. Okay, so the premium version of this course comes with a nice companion package. If you're on the premium version, then check out the download area for this lecture to download the package. Or if you're watching the free YouTube video, if so, then I'll tell you what you can do instead in a little bit. So download that package and import it onto a project. You can either import it onto a completely empty project or onto the actual project you're using to follow along with the lecture. Either way works. This companion package does not interfere with any other code. It is completely self-contained. So yep, here's the package. Just drag it inside the project. Make sure to select everything and import. Alright, yep, so here it is. Now this one contains a bunch of really nice helper windows. The goal of this companion project is to help you truly learn the contents of each lecture. For the windows, they're all up top over here. Under the menu CodeMonkey, over here you can find all the windows. So let's open up the main window. And yep, here it is. There's this nice window. Personally, I like to anchor it over here on the left side. So yep, there it is. This is the main window with a bunch of nice info. Here up top it says the totals, and over here you can see how many frequently asked questions and how many quizzes you've done. Now the goal is that by the end of the course you will have done 100% of all of these. That's your goal. So then we can click on the lecture list, with the idea being you watch a lecture, then at the very end you pause the lecture, and before going on to the next one, you come over here and you select whatever lecture you were on. Like for example, we just finished the Getting Started lecture. So let's go ahead and select that one. And yep, we can see this one has 7 FAQs and 7 quizzes. Then go ahead and select either of those. And yep, that pops out. In this case, pops out the quiz window. Then again, this one is a normal window, so you can dock it wherever you want. I like to put it over there next to the inspector. And yep, here quite simply just has a whole bunch of questions all related to the contents of that lecture. So the whole idea is to test your knowledge, to make sure you are actually paying attention, to make sure you're actually learning the contents of each lecture. So over here, for example, what is the purpose of the network manager in Netcode for game objects? So is it to manage the game physics? Is it to control character animations? Is it to synchronize UI elements? Or is it to handle connection, data, and settings for multiplayer? Like I said, if you're paying attention to the lectures, you should be able to get 100% of these questions right. In this case, yep, the network manager, that is the one that is used to handle the connection, data, and all the multiplayer stuff. So let's go ahead and select this. And yep, green means that it is correct. If we hit another one, it would show up as red and show the correct one. So yep, we got it right. And the answer is the network manager is responsible for starting connections, managing settings, and handling multiplayer specific data. It's the main component in Netcode for game objects. So yep, we can do this and we can either jump onto the next question or go back into the list, then click on the next one and go through it. So yep, these are the quizzes, and the other side we have the FAQs, frequently asked questions. So yep, here it is, another window. Let's also dock it over there on the side. And yep, here, same thing, a bunch of questions, all of them related to what we just learned inside the lecture. For example, what is the difference between server, client, and host? So let's see that, and here we have a nice answer. So the server runs the game logic but does not control a player, whereas the client, that one is just a player's connection to the server, and the host combines both server and client, allowing a player to host the game while playing. So yep, some nice extra helpful information, or really just reinforcing what we already learned inside the lecture. Then once again, we can go on to the next question, or go back and go through the entire list. Again, so basically the goal is, after watching each lecture, what you should do is go through all of these, go through all the quizzes, all the FAQs. For these quizzes, you should be able to get all of them right. If not, then maybe go rewatch a lecture or just write some code yourself. Again, I always advise that you make sure you fully understand the contents of each lecture before moving on to a different one. So make sure you get these right, then also go through the frequently asked questions. These might also answer some extra questions you might have yourself. What I can say is, if you do put in the effort to go through all of this learning content, if you go through all of that for every single one of the lectures inside this course, if you do that, then you will truly learn the contents of this course, and you will truly gain the ability to make any multiplayer you can think of. So I highly recommend you do this. After you reach the end of every lecture, pause, come here, go through all the questions, all the frequently asked questions. Make sure you get everything right to make sure you are actually truly learning. And if you're following along in the free YouTube video, if so, you can still do this. You don't have access to this companion project, but at the end of every lecture, there's a screen containing the titles for all the quizzes and all the FAQs. So if you're watching the free version, you can use those to guide yourself in your own learning journey. The companion project makes that much easier. So if you can't afford it, very simple, just go through the pre-prepared path that I prepared for you. Just go through that and you gain all that knowledge. But if you can't afford it, then really just need to put in a bit more effort yourself. You can find all the questions over there, and it's up to you to go find all the answers. Okay, so back here, those are just a few of the windows, but there are a few more. We've got the main window, frequently asked questions, the quizzes, and then over here we can see a bunch more windows. There is the companion window. So this is the CodeMonkey companion. This is basically a helper. This one is constantly analyzing your code, constantly analyzing the console. And if you do come across some errors, this will try to help you solve that error. So usually I like to dock it down here, put it right there. For example, I modified the code to intentionally throw an error. So as I click on this button, it is going to throw an error. So as I click, yeah, there you go, there's a nice error. And over there, the CodeMonkey companion, this one did identify that we found a null reference exception error. And over here, it tries to tell you a solution for that error. So in this case, for null reference, what I recommend is you use debug.log in order to figure out what exactly is null. In this specific case, I also have a dedicated video on this topic. So as you're making your game, if you encounter any errors, then hopefully this window will help point you in the right direction. Okay, so finally the last window up here is Chat with AI. Here it is, it's a very simple window. Here you've got an input and you've got a response. Like it says, you can chat with AI. This is a bot that was trained on the contents of the course, so it should be very good at answering questions specifically related to this, multiplayer games using netcode for game objects. Here you can ask whatever you want, like what is netcode for game objects? You can ask it, just hit on send. Then wait a little bit, and up here it says, what is netcode for game objects? It's a networking library developed by Unity for multiplayer game development and so on. As you can see, this one is near instant, so if you have any questions, you can go ahead, ask the AI. That will give you a near instant answer. Although of course, like I mentioned, you can always post questions in the comments, and I myself will manually answer within the next 24 hours. So yep, this is the companion project for this course. If you can't afford the premium version, then that's awesome. I intentionally designed this to really help you learn. Here you have a very guided path that I pre-prepared for you. All you have to do is follow the path and you will gain a ton of knowledge, but if you can't afford it, then that's fine. You really just need to put in more work yourself to find the answers to these questions that show up at the end of every lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up our grid so we can click on the various grid positions. Okay, so first let's build a simple grid to play our game. First let's handle the basic logic just locally, and then afterwards, after we have that set up, we will handle the multiplayer connection. So first, let's just build the grid visual. In the previous lecture, we already imported these nice visual assets. By the way, these are obviously just visual, so technically this is optional. If you want, you can use whatever sprites you want. These are all pretty basic, just a line, cross, circle, and a simple background. So if you want to make the game a little bit more custom, then go ahead and use your own visual assets. Over here, I'm going to be using these. So first, let's just set up a background just so we don't have a solid color. So let's create a new 2D object, a sprite, and we can choose any of these, doesn't really matter. Let's go with a square. Let's call this the background. And let's assign over here the background sprite. Just drag it. Yep, there it is. Now let's scale it correctly. So put it on an X of 13.7, Y of 16. Yep, there it is. Nice and occupying the background. And then importantly over here, the ordinate layer. This is what defines what sprites are on top of which. Like for example, let's say I go here and I create a brand new sprite. Let's say I create another square. And now if the background over here, the ordinate layer, the one on the square is on default on 0. But on the background, if I put it on 10, then that one shows up on top of that square. And if I put it on -10, yep, that one now shows up behind. So in order to make sure that the background always shows behind all of our sprites, let's put this one on -10. And then for all the other sprites we're going to add, all of those are going to be on 0. Okay, so yep, that's our nice background. Now let's position our grid. So for that, let's create a new 2D object, new sprite. Again, doesn't really matter which one we pick. Let's say this is the align, and let's drag over here the align, this one, the yellow one, yep. Then this one over here on draw mode, let's select sliced. That is because over here on the import settings for this texture, for this one, I open up the sprite editor. And over here, you can see how I drag the borders. That way we can use sliced, which means that it will scale the part in the middle, but it will not scale the edges. So it will always look pretty nice. So yep, over here on the line, select it as sliced. So over here on the scale, let's go with 6 and then 1F. And then over here on the width, let's go 1.65 and then 0.7 on the height. Yep, there it is. There's our nice line. Now for the position, basically we want 9 grid positions. So let's lift this one up a little bit. Let's say by 1.5 over there on the Y. Then let's duplicate this line, put this one on -1.5. Yep. Now duplicate this one again, and now let's actually rotate it. So let's rotate it exactly by 90 degrees over here on the Z. For the position, let's put it on the X -1.5, Y of 0. Yep, exactly like this. And then let's duplicate this one, put it on a X of +1.5. Alright, yep, so here we have our nice simple visual grid. We've got our 9 positions where we can now play our tic-tac-toe game. So now for being able to actually click on any of these spots, for that, just like with any programming problem, we have multiple possible solutions. For example, we could just use math just to check the mouse grid position. So just check if the mouse is to the left of this position over here, this little X. If so, then we are clicking over here, then check the Y under here, and we can figure out we are here. So we could technically just use math, or another alternative is to build the entire game just inside the canvas and use mouse clicks inside of UI buttons and things like that. We could also use a normal grid system, just like I've built many times in my tutorial videos. Or perhaps the simplest approach of all, we can just create some normal 2D sprite renders, add them to the colliders, and then just check when we are clicking on those renders. Like I said, that's the simplest approach, so let's go exactly with that one. So over here on the hierarchy, let's right click, let's construct, let's go with a nice square. And yep, there's our nice square. And now we just need to scale it basically to make sure that it matches up with that size. Let's put x of 2.6, y of 2.6. Yep, just like that. So this is just a sprite. In order to make sure that we can actually capture the clicks, for that over here, let's add a component and let's search for a box collider 2D. Again, importantly, choose the 2D one. We are making a 2D game. So use box collider 2D and not this one. This is the 3D collider. We want this one, the 2D one. So if there it is, and by default, the collider will already have the exact same shape as our sprite over here. Just make sure you are using the default square, and over here on the scale, set it like that. So if there it is, we have this. Now let's just go ahead and make a prefab before we duplicate all of them. So let's make a folder to keep things organized. So a new folder for our prefabs. And let's just name this one first, call it a grid position, and let's drag it inside the prefabs folder. Yep, there it is, our nice prefab. Okay, so now this one we can basically just duplicate and position it everywhere. So let's duplicate. Now on this one, let's put it over there on an x of minus 3.1. That is going to be the size of our grid, 3.1. Then let's put another one on x of plus 3.1. Yep, there it is, we have all of those. Let's duplicate all of these, and on the y, let's put it on plus 3.1. Duplicate these three again, put it on a minus 3.1. And yep, just like that, here we have our nice grid positions. Let's just give them proper names just so we know what object is which. So this one over here, let's use, for example, a nice index number. So for example, this one over here, this one is going to be on index 0, 0, and this one over here is going to be 2, 2. So let's name this. So this one, rename this to 0, 0. Then let's see this one on the side, 0, 1, 2, so 2, 0, 1. So this is the 2, 1. Then this one over here is going to be the 2, 2. This one over here is going to be 2, 0. This one over here is going to be the 0, 2. This one is going to be the 0, 1. This one is the 1, 0. And finally, this one is the 1, 2. So yep, we have all of our nice grid positions. And now we don't actually need them to have a visual. They really just need to have the box collider. So we can actually go inside the prefab. Let's modify the prefab so we modify all of them. And over here, let's just disable the sprite render. And yep, that's it. So now everything is invisible, but the objects are still there. Importantly, all the colliders, those are all still there. Okay, great. So far, so good. Everything is placed correctly. Now let's just make the script to handle each grid position. So let's make a script, and before that, let's keep things nice and organized. So let's actually make a folder. So a new folder for our scripts. And inside, let's right click, create a new model behavior script. Let's call this just grid position. Let's wait for the script to compile. Let's select the prefab, and over here, let's attach it onto that prefab. Yep, let's open this script. All right, so here we are, and we don't need these manual functions. Nope, so let's get rid of those. Over here, in order to listen to when the player clicks on a grid position, for that, we can use with a nice built-in Unity function that is called onMouseDown. Yep, there it is. This one is basically going to trigger whenever we press the mouse down on some kind of grid position. Also, make sure you write the function exactly, so it has to be exactly like this. Capitalization does matter. So if you write on mouse down like this, it will not work. If you put it on mouse down like this, it will also not work. So make sure you use the perfect capitalization just like this on mouse down. So yep, like I said, this function will automatically be called whenever we click on top of this collider. So let's just do a debug.log. Let's just print, click, and see if we get it. So yep, let's save the file. Over here, let's wait for it to compile. And again, make sure that on the prefab itself, make sure it does have the box collider, make sure that one is enabled. If it does not have this collider, then it will not trigger, but like this, we should see the message, so let's test. Also, by the way, the camera is set up like this by default. We want it as orthographic, that is a normal 2D camera, and over here I've got a size of 5, so all with defaults. Okay, let's test. Okay, so here we are, and if I put the mouse over here and I click, and if there you go, we have a nice message. So we can click on either of these positions, yep, we have message, and if I click outside where there's no grid position, obviously nothing happens. Alright, awesome. By the way, just one quick note here. Like I said, every programming problem has multiple ways of being solved. For example, there is another way of handling clicking on your objects. Now, if you're following along, if you're writing the code as you're watching this video, if so, then don't write this next part. I'm just going to show a different method, but we are going to use this method. So the other method is, instead of using this onMouseDown function, instead of that, if you want, you can use the event system. So for that, we just need to implement an interface. It is called onPointer. Either we have the down handler or the click handler, either one works. So this one requires us to implement a function. So let's implement this one, the onPointerDown. So let's do a debug.log, say onPointerDown. Yep, like this. So now if we select the main camera, and over here on the main camera, let's add a component, and we can search for Raycaster. And up here we see a bunch of options. So we have the graphics Raycaster. This is one that is used by the UI. This is one that allows you to click on UI elements. And then we have the Physics 2D and Physics 3D Raycaster. So in this case, we are making a 2D game, so let's add the Physics 2D Raycaster. This is what is going to allow that function to be called. And secondly, in order for this to work, we need to make sure we add a event system. So let's go over here and create, under UI, create a new event system. Yep, there you go, just like this. And now if we hit on play, so now if I click over here, and if there you go, we have the normal click and we have the onPointerDown. So like I said, two separate methods for finding clicks on your grid positions. We can use the onMouseDown. That one just use normal colliders and nothing else. Or we can use all sorts of iPointer interfaces. There's a bunch of these. Then you can implement the functions. In order to make sure that one works, you just need to have an event system on your project. And on the main camera, it needs to have a Physics 2D Raycaster. So yep, these are the two nice ways of capturing mouse events. Like I said, let's use the simplest one of all. So let's use just the onMouseDown. Let's get rid of this. We don't need that, so just a simple script. And over here on the main camera, let's get rid of the Physics 2D Raycaster. And down here, also delete the event system. Okay, so we're back to normal. Let's hit on play. And if I click, and if there you go, this works. Okay, great. So we can now click on any of our grid positions. However, we don't really know where we clicked. We just have the same click message wherever we click, doesn't matter where. So let's just store the X and Y coordinates of our grid positions. For that, over here on the grid position, let's just add those. Let's add a serialized field, private, int X, and another one for int Y. By the way, if you don't know this attribute, the serialized field, if you don't know why I use this and why I made this private, if so, then you can definitely go watch my dedicated video on this topic. It's a very, very important topic. Basically, you want to avoid making fields public as much as possible. There's almost no scenario where you want to make a field public. The issue is that when you make this public, when you do that, you make it so that any code anywhere in your entire code base can both read and write to that field. So if you have a game with, for example, 1,000 classes, then any of those 1,000 classes, any of that code can modify your field and potentially break the rest of your game. If the field is not meant to be accessible by any other class, like here, we really just want to store some data. We don't want it to be modified afterwards. We don't want other classes to be able to modify the grid position coordinates. Because of that, in this case, this should be marked as private, meaning that only this class can read and modify this field. However, if we make it just private without serialized field, if we do just this and we hit on save, like this, then over here in the inspector, yep, look at that. The Y field does show up, but the X does not show up. Basically, if you make something just private, it does not show up in the editor. So in order to keep it private, in order to be safe to the rest of the code base, and also to be editable from the editor, to achieve both of those, we make it private and then add the serialized field attribute. So yep, just like this, private int X, private int Y, let's go ahead and save. Like I said, definitely go watch my other dedicated video on this topic, it is extremely important. So now here in the editor, yep, we can see this grid position, and this one over here is meant to be the 1, 1. So let's go ahead and assign all of them. So this is the 1, 1, then on this one, it is the 1, 2, then this one over here is the 1, 0, then we have the 0, 1, then we have the 0, 2, then 0, 0, then 2, 1, then we have the 2, 2, and finally we have the 2, 0. Alright, yep, so all of them have been assigned the correct values. And over here on click, let's just print those out. So let's print the X and then the Y. Okay, yep, just like this. Let's do a quick test. Okay, here we are, and over here on the bottom, this should be 0, 0, so if I click, yep, there you go, 0, 0. Up here on top should be 2, 2. Yep, there you go. This one should be 1, 1, and this one over here should be 2, 0. And if there you go, everything works. So wherever we click, we are both capturing the click, and we are also capturing what exactly is the grid coordinates that we clicked on. Okay, great. So now we have nice and clickable grid positions, and we also have the ability of knowing where we clicked. Again, so far, all of this is just local single player stuff. We're not doing any connection, any multiplayer stuff just yet. Don't worry, we're going to get to synchronizing that data in a little bit. Now that we have the clicks, let's make a general GameManager script that is going to listen to those clicks and be able to do all kinds of things. That is going to be the script that is going to run the main game logic. So let's make that script in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create a GameManager class that will handle most of our game logic. And in doing so, we're also going to learn about the very important Singleton pattern. So we have previously set up our grid position, so we have all of those clickable areas. If we use the mouse and we click on any of those, yep, we are capturing the click as well as the actual grid position where we clicked on. For handling most of the logic in our game, we're going to make a main GameManager class that is going to handle it. So basically, as we click on this is going to pass in this coordinate onto that class. So let's go ahead and make that. So over here in the project files, on the scripts folder, let's create a new MonoBehavior script. Call it just the GameManager. Let's wait for it to compile. Then let's go ahead, create a new empty game object to run this, the GameManager. Let's drag our script on there, reset the transform, and open. Okay, so yep, so like this. Let's make a function that we're going to call whenever we click on a grid position. And let's make it public since we are going to call it from a separate class. Let's make it return void, don't need to return anything. Let's call it clicked on grid position. And we're going to receive an int x and an int for the y. Simple like this. Let's do a log just to verify everything is working. So log on the clicked on grid position with the x and with the y. Okay, yep, like this. So now the question is, how do we actually call this function from over here from the grid position? And to solve this problem, we mainly have two options. And again, like I said, over here on this course, I am teaching you proper production quality code. I am not teaching quick-and-dirty code. What I'm teaching here is exactly what I would do in my own professional game projects. So over here, we have two options. One option would be we can make a serializable field of type GameManager. We could do this, and then over here, if we look inside of the grid position, yep, over here we have the reference, so we could then just drag the GameManager reference. We could drag that reference onto all of these grid positions, and then over here when clicking, we would go inside that one and call that function, clicked on that, passing the x and y. So this is one option, it's one valid option, but it is a little bit annoying to be forced to drag 9 references for our 9 grid positions. That is a bit prone to error. If you forget to drag one, then this line is going to throw an error. So instead of doing this, instead of dragging the reference for the GameManager directly onto our objects, instead of that, let's learn about the very useful Singleton pattern. This is a really awesome programming pattern. In game dev, it's really one of the most useful ones. I have an entire lecture on it over here in my C# course. Basically, this pattern is a way for you to have just a single instance of something and a very easy way of accessing that one reference. Now, in this case, we do intentionally want to have just a single instance of our GameManager class. There should only ever be one of this. We should never have 2 or more. So the Singleton pattern makes perfect sense here. And the way we define the pattern is actually quite simple. First, we define a public static. Then for the type, this is going to be a GameManager type. And for the name, usually the standard name is just call it instance. And then this one is usually a property, and the property has a public get and a private set. Again, if you want a really detailed explanation, then check out my C# course. I have lectures on both the Singleton pattern itself, as well as what exactly is a property and what exactly is static. I really don't want this video over here, this one, to end up being multiple hours long, so that's why I'm pointing you to those lectures. As just a quick explainer, static means that this field will belong to the class itself and not any instance of that class. And a property really just means that it's a normal field with a get and a set. So properties are sort of a mix between fields with some functions. And specifically, we want to use this property to define our Singleton pattern for one very simple reason, and that it is because with properties, we can easily define the accessors for the get and the set. So over here, we make this property public, and in doing so, over here, the get is also going to be public, but then the set over here, the one for assigning this field, this one is marked as private, meaning that only this class can set this property, but any other class in our entire code base can get it. That's exactly the level of accessibility we want for our Singleton field. So just like this, and then let's just make a normal private void awake, and on awake just set the instance equals this. So yep, that's it. This is the Singleton pattern, super easy. Although just for safety you can add a little bit extra. Like I said, the Singleton pattern should only have a single instance. So over here on awake we can check if the instance, if that one is not null, that means we actually have a double instance. That should not happen. So over here, let's just do debug log error more than one GameManager instance. So if this happens, then that's a bug, and we should really make sure we only have one GameManager. And if we just have one, then everything will work perfectly. Okay, great. So now basically we have set up this field. This is a static field, so it's very easy to access. Now over here on the grid position script, we can just go inside the GameManager. We can access the static instance, and through that we can access any public function. So for example, clicked on grid position, this x and this y. Yep, there it is, just like this. Let's save both of our files, and let's test. So now here we are, and if I click on this, and if there it is, we have both of our function calls. So we have the local one and the one inside the GameManager. Alright, awesome! So here we added the ability to be able to click on any grid position and be able to have a general GameManager script that listens to all of those clicks. So instead of having these functions all being called on separate objects, instead of that we have these all being called on the same object. So we have a nice script that knows everything that is going on inside our entire board. Now that we can click on things, the next important thing is to be able to spawn some visuals. And doing so, we're also going to finally synchronize some nice multiplayer data. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create a game visual manager to spawn our visual objects. And that means we're also going to learn how to spawn objects on the network. Okay, so here we have our grid positions and we can click on them. Now let's actually spawn something, and then we will see how to synchronize that spawned object on the network. So here on the project files, we already imported these nice visuals. We've got the cross and the circle, that's basically all we need to make this game. So let's begin by making the prefab, so let's create a new empty game object. Let's call it just the cross. And again, like I said, over here I'm teaching you the proper way to handle things. And the proper way, or at least the proper way that I normally make my games, is I normally have a parent game object, and on that one I just have all sorts of logic components. And then for the visuals, usually I separate them. So for the visuals, I usually place them as a child game object. So over here inside the cross, let's create a new 2D object. Let's make it a sprite. And yep, that way the sprite is separate from the main game object. So the main components are going to go here, and let's just reset the transform. So this main game object, this one handles all the logic components. And then on this child, then we have the nice visuals. That way we have a really nice separation. And secondly, it also allows things like, for example, over here on the main game object, this one has a scale of 1, 1, 1. And if we want to scale the sprite, like for example, if I now drag the cross sprite, there it is way too small. And if I were to update over here the size on the parent, if I do this, then this might break other kinds of things that might assume that the main game object has a scale of 1, 1, 1. So in order to not break any of those possible things, we just leave the main game object, again, just the logic components, and always with normal scale. And then on the sprite child, on this one, we can scale it as much as we want. So yep, it's always great practice to try to separate the visuals from your logic as much as possible. That is why I always follow this pattern. Logic components on the empty game object, and visuals on child game objects. So yep, just like this. On this one, let's just name this the sprite. And over here for the position, make sure it's on 0, 0, 0 with a scale of 2.6. Okay, yep, there's our nice sprite. Now we can make this a prefab, so let's just drag it inside the prefabs. Yep, there's our nice cross. Let's also duplicate this, make this the circle. And for this one, let's double click to go inside of it. And over here on the sprite, let's just use the other sprite. All of it exactly the same size, everything the same. Okay, yep, so just like this. Here we have both of our nice prefabs. And now for spawning them, once again, let's do it properly. So let's make it so that this GameManager class, this one just handles the logic. And then let's make a separate class to just handle the visuals. That way everything is nice and separated. So let's make a script to handle that. On the scripts folder, let's create a new mode of behavior for the game visual manager. Let's wait for it to compile. Then over here, let's make an empty game object with the exact same name. Let's reset the transform and attach the script. And also let's remove this prefab over here from the scene. Okay, so now let's open the game visual manager. On this one, let's begin by adding references to our prefabs. So again, let's do it properly with serialized field private. Let's make it of type transform. By the way, over here you can either use transform or game object. Those two types are mostly interchangeable. I cover the difference over here in this tutorial. So as a preference, I just usually prefer to make transform, so let's use that. Let's make one for the cross prefab, and another one, this one is going to be for the circle prefab. Okay, yep, we have both these references. Then over here in the editor, there's the fields, and let's just drag. So the circle over there and the cross over there. Okay, great. So now in the game manager, over here when we click on a grid position, again, we don't want this class to be tightly coupled with the visuals class. We want the game to work with or without visuals. So as always, let's write some good clean code. Let's decouple the game manager from the game visual manager. And the way we're going to do that is using some really nice events. Now, if you know nothing about events, then check out my lecture on that topic in my C# course. It is a really awesome C# feature, definitely one of my favorites. So here, when we click on a grid position, for this, let's just fire off an event. So let's go up here to define our event, public event. Let's make it the standard event handler and call it on clicked on grid position. Okay, yep, so this is the event. And on the other side, on the game visual manager, we need to know the coordinates of where we clicked. So let's add some extra data onto this event. So let's make a class on clicked on grid position event args, and let's extend event args. Again, if you don't understand this code, then make sure you go watch my C# lecture on events. The event handler, this is just the default delegate, and making a class that extends event args is how you can usually pass in extra data for this event. So in this case, let's pass in the int for the x, another int for the y. Okay, up like this, and then down here, let's just invoke this event. So let's invoke, let's use the question mark so we don't have the null reference, and let's trigger invoke. For the object sender, pass in this, and let's construct a brand new event args object. Inside this one, put the x equals this x, and the y equals this y. Alright, yep, so we have this nice event, and then over here on the game visual manager, we can just listen to that event, and for listening, let's do it on start and not on awake. Once again, that's yet another really nice clean code principle. When making your games, when making your Unity scripts, for initializing something, you have either the awake or the start. The awake runs first and then the start runs afterwards. And usually my rule for managing these is if you want to initialize this particular object, if so, you do it on awake. But if you want to access any external references, you do those on start. Over here, we want to listen to the event on the game manager. So we go through the game manager, access the static instance, and listen to the event. So let's assign a listener like this, the game manager. So because over here we are accessing the static instance, this is an external reference. Because that, we put it over here on start. Whereas, for example, over here on the game manager, note how for initializing this field, this one which belongs to this class, for this one, we initialize over here on awake. This is just a simple rule, so use awake for initializing the current object, and use start whenever you access any external references. Just by following that simple rule, you are going to solve so many possible problems. If we were to run this over here, run this line of code on awake, then we might or might not end up seeing an error. It all depends on how Unity decides to compile both these classes. If it were to run the game visual manager before the game manager, we would have a null reference exception over here. But if over here on the game manager, we initialize this on awake, and on the visual manager, we only access the external reference on start, if we do this, then we know for certain this one is going to be set, so we don't have any errors. So yep, just a quick explainer on the difference between awake and start. If you just follow that one simple rule, you are going to solve so many issues. Alright, so here we are listening to that event, so this class now knows exactly when we click on a grid position and what grid position we clicked on. So over here, let's just spawn something, so let's just call instantiate. Let's spawn our cross prefab object, and then for the position, for this one, let's make a nice helper function to get the world position for a certain grid position. So over here, let's make a private, return a vector2, get the grid world position, and this one's going to take an int x and int y. So for converting it, it's actually going to be quite simple. So over here, let's just comment this out so we don't have the error. We're basically just going to return a new vector2. This one is meant to be the world grid position. And for knowing the world grid position, we really just need to know the size of our grid. And over here, we define the grid as having a grid size of 3.1. For example, let's just put a cross over here on the scene just so we can test. And we can see, for example, the center position, that one is on 0, 0. And the one over here is going to be on minus 3.1. Yep, this is the one. And then over here, that one is going to be plus 3.1. And same thing on the y. If we want to go up there, that's 3.1. So yep, this is the size that we defined for our grid, 3.1. Meaning that in order to calculate it, so for example, over here, position 0, 0, we're basically going to start from the offset of minus the grid position. So minus 3.1, minus 3.1. So if the grid position is 0, 0, then we're going to be here. If the grid position is 1, 0, then we start from minus 3.1, and then we add plus 3.1. So yep, we end up in there, and if we have 2, 0, then we have this one plus 3.1, just like that. So basically we start from the offset, minus 3.1 on the x and y, and then we add the grid position multiplied by this grid size. So yep, like this, let's delete this object. And over here, for defining the grid size, for that, since it's something that is never going to change, for that, let's define a nice constant. So let's make a private const, make it a float, call it grid size. In this case, grid size is 3.1f, okay? So then down here, let's just do exactly what I said. So we start from minus the grid size, plus the x multiplied by the grid size. And same thing for the y, minus the grid size, plus the y multiplied by the grid size. Okay, yep, so this gets the grid world position. So over here, we can instantiate on this position. Let's access the event args, so the e, and inside we have the x, then e.y. And then for the quaternion rotation, we don't want any rotation, so let's just use quaternion.identity. Okay, so yep, just like this. Like this, when we click on a grid position, we should be able to see the cross prefab being spawned on that position. So yep, let's save our files and let's test. So over here, and if I click down the middle, yep, there it is, the nice X. And now if I click over here on this corner, yep, it spawns there, and it spawns on all of those, so whatever I click, it spawns on the perfect position. Alright, awesome. Now let's test this in multiplayer. So on multiplayer play mode, let's open up the second player. Let's make sure to save our scene. So let's play both of them. Then on the main one, let's choose the network manager, and over here, let's start a host. Okay, then on this one, network manager, let's start as a client. Okay, we have a connection, and on this one, if I click, and nope, nothing really happens. The connection is established, we can see some bytes are being sent, but whilst we did spawn this over here, we spawned this object locally, it did not spawn across the network. Now this is actually working as intended. If I click on this one, it also does not synchronize the other way. Basically right now we are just spawning local objects. If we want them to be spawned on the network, we need to actually spawn the object on the server. We need to do that to make sure the object is synchronized across all of the connected clients. So the way that we do that, first of all, is we need to define our prefabs as being objects that can be spawned on the network. And for that, let's go over here on the prefab, let's add a component, let's add the network object component, this one right here. So this component over here defines that this is an object that should exist on the network. So let's add it over here on this one, and also on the circle, let's add a network object component. Then we have all kinds of settings, but we can leave all of these as defaults. Then over here on the code, when we instantiate, let's grab the object that we spawned. So our transform for the spawn cross transform. And then on this one, let's call get component. Let's grab that component that we just added, the network object, which exists inside the namespace using Unity.Netcode. So we have this one, and then inside that component, we have a function called spawn, and then we have an option if we want to destroy it when the scene gets destroyed. Right now it doesn't really matter because we just have one scene, but either way, let's put it as true, just like this. So yeah, basically this function call over here, this one is telling the network object that this object should be spawned across the network, meaning it should also be spawned on all clients. Now before we do a quick test, let's actually do 1 second thing, just so that later on we can see something different. So over here, instead of instantiating like this, spawning it directly on this target position, instead of that, let's actually spawn it on 0, 0 and then move it. So for the spawn cross transform over here, let's set the position equals to this one. And for the instantiate, we'll literally just instantiate that prefab. Again, I'm doing this just to show an interesting networking error that we're going to see in a little bit. So let's do it just like this. But right now, let's verify that this one is working. Let's verify that it is spawning on the network. Okay, so let's save. Okay, so let's connect on Network Manager. On this one, start a host. And on this one, Network Manager, start a client. And now on this one, again, this is very important. On this one, on the host, here, let's click to play something. So if I click, and if there you go, it did work. You can see as soon as I clicked here, it spawned the object actually on both the host and the client. Now the position is wrong. Like I said, that is something we're going to see in a little bit, so don't worry about that for now. Here we did manage to spawn an object across the network. However, then down here, let's go on the client window. And on this one, I'm going to try and click. So as we click, and if there it is, here we have our error message. It is a not server exception. It is telling us that only the server can spawn network objects. This is a very, very important concept in making any multiplayer game. Usually in multiplayer, there is an ultimate source of truth, and that one is usually the server, meaning that only the server is allowed to spawn objects. Clients cannot spawn objects by themselves. Basically, only the server is allowed to modify certain data that we're going to see. That data is spawning objects and also a bunch of other things. Now, I said usually because Unity recently added a different ownership mode. That's what we saw a while ago, the distributed authority. That mode means that multiple clients can have authority over different objects, not just the server. But that is a more special use case. Again, over here, like I said, we're keeping things simple, so we are not using distributed authority. Over here for this one, we do want this game to be server authoritative, meaning that only the server has the ability to spawn objects, so this is very much intentional. Which then of course begs the question, so if the server is the only one that can spawn objects, how can we ever have the client actually take actions? How can the client actually spawn objects without actually spawning those objects? In order to solve this problem, we're going to learn about one very, very important topic in multiplayer game development, that is RPCs. So let's learn all about that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn all about RPCs. These are basically just simple messages. This is what is going to allow us to solve our previous problem and ensure the server is the only one spawning objects. Okay, so here both clients are connected, and if we click on the server, it does work without issue. However, if we click on the client, yep, there it is, we have the error, only the server can spawn network objects. So this is our issue. How exactly do we solve this problem? Thankfully, it's actually quite simple. We really just need to make sure that the function to spawn the objects, that one only runs on the server and never runs on the client. Essentially, we need the client to basically tell a message to the server for the server to run some function, as opposed to the client running that function locally. So yep, to solve that, that is why we have something called RPCs. Those are remote procedure calls. Basically, it's how you can send a message from the client to the server, or vice versa. And that message is really just telling the code to run a specific function. So over here, like I said, for instantiating, for running this line of code, this one can only be run on the server. So let's make a server RPC. So first let's actually make a function. So private void, let's spawn something, spawn an object. Let's pass in int x and the int for the y. Let's put this code over there, and then we call that one, spawn object. Pass in the e.x, e.y, and over here let's use just the x and just the y. Okay, so we still have the exact same code. The only way I did this is so we can make this separate function an RPC as opposed to making the function that is going to listen to the event an RPC. We're just separating it. So yep, we have this one, and the way that we mark this function as an RPC, for that we add the attribute, and the attribute is called just RPC. By the way, technically they are these two. These are from previous versions of Netcode for game objects. Nowadays we have just this one that can work both as a server RPC or a client RPC. So we add this attribute, and over here let's open up the parentheses, because this one takes some optional parameters. And we can use this version over here that has a send-to, so let's write send-to. And here we see all kinds of options that we can use. So we can send this RPC to who has authority, to clients, everyone, just me, whoever has not authority, whoever is the owner of the server, and so on. Like I said, for this one, we want to run this one just on the server. So yep, let's go ahead and choose this one, send to server. So let's use this nice attribute. And yep, this is how we mark an RPC. Basically, if a client runs this line of code, so when the client locally is going to call this function, instead of running this code locally, instead the client is going to send this RPC message onto the server, and then the server is the one that is going to run this function. So by doing this, we make sure that the client is never ever going to run this, only the server runs this line of code. Let's do a log so we can see that in action. Let's do a log spawn object, and let's also do a log up here so we can see exactly what side gets what message. However, we still need to do one more thing. Another rule that RPCs have is they need to have RPC at the end of the name. If we do it just like this, yep, here we do see an error. The RPC method must end with the RPC suffix. So when rules for RPCs, we need to append RPC at the end of the name. So let's add it right here, like this. Yep. However, again, just like this, it still won't work yet. We're actually missing one thing that I've forgotten many times, and it always drives me crazy. If we do it just like this function will not be called exactly as an RPC. It won't just run locally as if we didn't make this an RPC. In order to make this work as an RPC, in order to make this attribute actually work, for that, up here, instead of inheriting from MonoBehavior, this is the standard script that all Unity scripts inherit from, instead of this, for netcode scripts, we need to inherit from network behavior. This is very, very important. Again, if you don't swap MonoBehavior to network behavior, then the RPCs are really not going to be treated as RPCs. They're just going to run as normal functions. So make sure you don't forget this. Make sure you swap MonoBehavior for network behavior, and this way the RPC won't work. Again, I'm repeating this because I've made this mistake many times. I forget to use network behavior, and then I have no idea why exactly the RPC isn't working. And the answer is very simple. Just script needs to extend from network behavior. So yep, don't forget this. Here we have all of our code working. We have all of our logs so we can verify exactly how it is running. So let's go ahead and save this. And the final thing that we need is over here on this object, the one that has the game visual manager. On this one, we need to make sure to add a component, and we need to make sure to add a network object component. Again, this is the component that defines that this object exists on network. If it doesn't have that, then it will not exist on network. So to summarize, in order to make sure the RPC works, it needs to have the RPC attribute. This script needs to extend from network behavior instead of MonoBehavior. And finally, the object that script is attached to needs to be marked as a network object. Okay, so with all of that, we can now test. Over here on this one, let's make it a host. On Network Manager, start host. And on this one, Network Manager, let's start as a client. And now up here on the host, let's click somewhere. And if there it is, we can see all of our function calls. So we got the click, so that's the local click on the grid position. We got this one on the game manager. Then we've got the event listener. And then we have the spawn object. This is the RPC. So yep, it makes sense. Again, this one is the host, meaning it works as both the server and the client. So it makes perfect sense that it's running all of these. And now let's go down here onto the client. And now if I click somewhere, yep, there you go. First of all, it worked. We have no errors. And we can see over here on our logs. So it still got the click. So that's the grid position. It got this function. This is the one on the game manager. It also got this one. Listen to the event. However, the spawn object, this one is not running here. So even though the client called the function supposedly like normal code, because it's an RPC, it did not execute that function over here. Instead, it just sent a message to the server, and the server is the one that ran this function. And doing so, of course, we solved that problem. The object is spawned, but it is now spawned only on the server, even though the client was the one that directed that object to be spawned. So yeah, awesome. This is how we can spawn objects and make sure we don't have issues on client or server. We use RPCs to make sure we run some kind of function either on client or server or wherever we want. This way now the client can take actions and actually spawn objects. The only issue we have right now is that the position is not being synchronized. So on the server I clicked over here, but on the client it listened to the object being spawned and positioned it here on 0, 0. And then the client I took an action over here, but again, same thing, just spawn the object on 0, 0. So the position for the object being spawned is not being synchronized. So for that, let's learn about another very useful feature of Netcode for game objects, the network transform component. So let's learn about that in the next lecture. Alright, quick intermission here. How are you getting along with the course? Are you finding it relatively straightforward? The tools really are awesome nowadays. Compared to how difficult it was to make multiplayer games when I got started, compared to back then, these tools are really excellent. It is impressive how you can make a multiplayer game in literally just a few seconds. So yep, I do hope you're learning quite a lot. I hope you're also taking your time to do all the quizzes and frequently asked questions. And of course, if you get stuck on anything, remember how you can download the project files to compare directly with your own. Or if you need some deeper explanation, or there's something you just don't understand, then post in the comments and I'll do my best to help. Alright, so let's keep going. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the network transform component. This is a super simple component that allows us to synchronize our transformed data. Okay, so synchronization of spawning objects is already working. So if I click to place here, yep, it works, no errors, and it places the object and gets synchronized across the client. And if I click on the client, yep, it works, no errors, and it spawns the object. However, the position is not being synchronized. Over here, the client is indeed listening that objects are being spawned, but for the position, it is spawning them just on 0, 0, is not actually spawning them where they should be. So essentially this code over here, when we instantiate the object and spawn it on the network, this part is working, but then when we move the object afterwards, this part, this function call over here, this one is not being synchronized. So the transform position does not get updated after being spawned. By the way, this is the reason why I said to do it like this, first instantiate and then move it. Because if you instantiate on the correct position, then technically everything will work and you don't need network transform. But we should learn about that component because it is so useful. This is a great teaching moment to learn about another very crucial thing in multiplayer games, which is how you need to explicitly tell what data you want to synchronize. Things do not get synchronized by default. Just like over here, we had to explicitly call spawn in order to spawn the object on the network. We also need to tell it to explicitly synchronize the data on this transform. Now thankfully, that is pretty easy. Netcode for game objects already comes with a very helpful component. So let's go select both our cross and our circle, and let's add a component. And the one we want is this one right here, the network transform. Yep, here is this component. Like the name implies, this one is going to make this transform exist on the network. And then over here we even have some nice checkboxes where we can define what data we want to synchronize. So we can sync pretty much literally everything, or we can sync only the things that we need. And you might be asking, okay, so why exactly is this optional? Why would you not want to synchronize everything? And the answer to that is that it's all about bandwidth. In multiplayer games, bandwidth is super important. You want your bandwidth cost for your game to be as little as possible, meaning that you want to synchronize as little data as you need to. One reason for that is that usually you get charged based on bandwidth. So if you have dedicated servers, the price you pay to your cloud provider will be dependent on how much bandwidth you use, so the less data you synchronize, the better. Over here in this game, for this object, for this, all we need is really just the position, the x and the y. The position z will never change, neither will any of the rotations or any of the scales. So because of that, we can just untick all of these checkboxes, so we only synchronize the x and the y. So yep, just like this, and just by doing this, everything should already be working. We can leave the rest of this as defaults. Again, we have the authority mode, we have the thresholds, delivery, and so on. Again, leave all of these as defaults. So just by doing this, without modifying the code at all, just like this, let's test. So over here on the host, if I go onto this one and I click, and if there you go, look at that. It spawned the object over here and instantly moved over there. Meaning that the client did get both the spawn position being synchronized and got the new position also being updated. And then same thing, if over here on the client I take an action over there you go, and then moves the object to the correct position. Alright, awesome. Now here also note how the object moved in a nice smooth fashion. That's the network transform interpolation in action. It automatically interpolates from the last position to the next position in order to make it look nice and smooth. However, in this case, we don't really want it smooth like this. We want the object to spawn exactly on the target position. So because of that, over here, let's actually revert back to the code that we had previously. Let's spawn the object directly like this, quaternion.identity. So we do it like this instead of spawning and then moving the object. And now here on the host, if I click, and if there you go, it spawns directly on the right position, both on that one and the client. And on the client, I click, and if there you go, it does work. So I can take actions wherever I want, and the object is both spawned and exists on the exact right place. So transform data is being synchronized, the spawn data, all of that is working perfectly exactly as intended. All right, awesome. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to define some player types and use the client ID to assign them. Okay, so right now our game is working. We can click to place objects on any position on the grid. So I can click to place the host and I can click to place on the client. But of course, there's an issue. Both players are currently playing crosses. We want one player to be playing crosses and the other one to be playing circles. Now, the simplest way to handle this is just to make it so that the server, this one is going to be the crosses player, and the client, this one is going to be the circles player. So before we do that, let's first actually define those two types. And again, let's do it properly. So for defining what is a cross and what is a circle, for this, let's not use something like a string. So let's not do this. Private string player type equals crosses. This is bad. We do not want to do this. Strings are terrible. Strings should only ever be used for text. They should never be used to identify some kind of type. So instead of strings, in order to do it properly, let's use an enum. So over here, let's define public so we can access it from anywhere. Make it an enum, name it player type, and inside for the values, let's begin with none, then cross, and then circle. If you don't know what are enums, I have a lecture on it in my C# course. Basically, they are super simple. They just define a collection of possible values. And so over here, the player type enum, this one has only 3 possible values. It can be none, cross, or circle. So yep, these are our possible player types. Now that we have defined the type itself, let's make a variable to define basically the local player type. So let's make a field, a private of type player type, and call it the local player type. Meaning this is meant to be the player type of the player that is currently running on this instance. So we have this, and then like I said, for assigning this, we want the host to be playing crosses and the client to be playing circles. So the way that we identify which one is the host and which one is the client, over here, we can make the script instead of a mono behavior, let's make it a network behavior. That way this script itself is going to exist on the network, which when we add this, let's also just make sure to save this. And then here in the editor, let's select the GameManager, and yep, let's make sure to add the network object. Whenever we have a network behavior, we need to add a network object to that same game object. Okay, so basically by using this network behavior, inside this script we have some really nice callbacks we can use. And one of those is when the objects actually spawn on the network. So over here, let's make that one. Let's do a public override, override void, and the one we want is this one, the on network spawn. So if we override this one is basically going to run whenever this object is spawned on the network, which means that at this point we have a connection active. So another super useful thing we can do is we can access the network manager, access the class itself, and then inside it we have a singleton. So this is exactly just like the singleton instance that we created here. It's just a different name. Unity decided to call it instance as opposed to the standard instance, but it's really the same thing. So we can access the singleton for the network manager, and then inside we can grab the LocalClientId. This is a long, so it's basically a number, and it's going to be the ID for the player that is currently running locally. So on this one, let's just do a debug.log to see what this one says. So let's say on network spawn and then print that one. Okay, yep, so like this, let's test. Okay, so here the game is running, and first of all, note right away how that function is not running. The on network spawn, that one did not run. That's one way that you can see how this function is actually quite different from awake or start, meaning it does not run instantly, it only runs when there's an actual connection. So now over here, let's make a host. So on the network manager, let's start a host. And if there it is, now it does run. It calls on network spawn, and this one has a client ID of 0. And now on the client over here, select network manager, and let's start as a client. And if there it is, on network spawn, and this one has an ID of 1. So yep, like I said, we can use this. So if the ID is 0, then this one is going to be the crosses player. And if the ID is 1, then this one is going to be the circles player. So over here, let's do that. So do an if on this. If on the local client ID, if that one equals 0. If so, then the local player type, this one is going to be the cross. And if not, then we are going to play as the circles. So yep, just like this. And over here on the game visual manager, we want to spawn the proper visual. So over here, when we are spawning the object, over here, we want to choose a prefab. And here we actually have a very interesting question. Now, the first thing you might think to do is, for example, over here on the game manager, let's expose the local player type. So public return a player type, get the local player type. We make this function just return the local player type. Okay, so yep, here we are exposing it. And then over here on the game visual manager, let's do a switch, go inside the game manager, access the instance and get the local player type and do a switch on it. So case it is a cross, then we use the cross prefab, and if not, we use the circle prefab. So let's find here a transform for the prefab, and over here by default, if it is a cross, then the prefab equals the cross prefab, and if not, then prefab equals the circle prefab. So we have that simple switch, and then we use this prefab. So like I said, this is one way you might think to do this. So basically expose the local player type on the game manager in order to choose what prefab to spawn and then spawn it. However, this is actually a mistake. And if you want a quick exercise, then pause the video right now and try to figure out what the mistake is here. So let's do a quick test and see what exactly this is going to do. Okay, so here on the host, let's play. And if there you go, it does work. It did spawn across. Great. And now over here on the client, let's take an action. And nope, there it is. There's our mistake. This one spawned a cross as well. So yep, what exactly is our mistake here? It's actually quite simple. The mistake is because this one is over here, it's a server RPC. Which again, remember how that means that this function is only running on the server and not running on the client. So when this function runs and tries to get the local player type, it is not actually going to get the local player type, for example, if the client was the one spawning an object. Instead, it is always going to run locally, so this one is always going to return the server local player type. This is a mistake. Again, you always need to keep in mind what functions are run on the server and which ones are on the client. Now, thankfully, this one has a very simple solution. Over here on the RPC, we can really just add the player type as a parameter. So just add GameManager.playerType, and receive that one. Also, by the way, RPCs do have a bunch of limits when it comes to what parameters you can use. You cannot use just any type here. For example, one main limitation is, in general, you cannot use value types. So you cannot use any kind of object right here. This is not supported. You cannot have a game object, you cannot have a transform, and so on. If you do absolutely need to transfer some data related to some kind of network object, you also cannot pass in a network object. This also does not work. This one is also an object. If you absolutely need to do something like this, if so, then the proper way is to pass in a network object reference. Pass in this one, and this one is indeed a struct, so this one is a valid parameter. So that's just a side note on the possible types you can use in RPCs. And also in general, the difference between value and reference types, between structs and classes. If you don't know the differences between those, you can check out that lecture on my C# course. Thankfully over here, we don't actually have those problems because we made player type an enum, so we can use those directly over here as a parameter on an RPC. All we need to do is really just pass it in. So let's modify, first of all, this event. So over here on the event, pass in the X, the Y, and also the player type for the player type. And then down here, when we invoke the event, when we do, let's pass in the player type. So player type equals, and over here we can grab the local player type. That is the one that we're going to send through the event. And then when this one receives that, pass in e.playerType, which then passes on to that one. And then over here we can do a switch on this, and this is the one that we use in order to define which prefab we want to spawn. So yep, just like this, let's save. Okay, so now on the server, click, there you go, we've got a cross, and on the client, click, and there you go, we have a nice circle. All right, awesome. So everything is working great right now. We can play crosses on one side, circles on the other. However, we have one obvious thing missing. Right now, the player can take as many turns as they want. Right now, the game has no concept on what exactly is a turn. So let's do that. Thankfully, it's actually pretty simple. We really just need to keep track of a field on the server for who exactly is the next player, and only allow that one to take action. So over here on the game manager, let's define another simple field. Make a private of type player type. Call it the current playable player type. So this is the player type that can currently play. In order to initialize this, by default, over here on the enum, we made the first value none. Once again, that's just regular good practice. Usually you want the first enum value to be some kind of none, null, or invalid value. That way, anything you define by default won't be invalid until you actually assign it to a valid value. So yep, this one starts off as invalid. That's exactly what we want. And then for initializing this, we can just go over here on the onNetwork spawn. And over here, let's check if this is a server. So we can use literally just this, the isServer. This is a property that exists inside the network behavior. So since we extend that, we can use this. So if it is a server, then let's set the current playable player type equals the player type, and let's say the cross plays first. Okay, yep, just like this. And basically the reason we are doing a server check is just because it doesn't really matter what the client sets this to. It really only matters on the server. Remember how this game is server authoritative? So even though this field will exist both on the server and on the clients, this one really only matters just on the server. Okay, so we have it like this. And then over here, when we click on a grid position, over here, let's check if this player can take a turn. So here, let's check if the local player type, if that one does not match the current playable, then this one is not playable, so let us not do anything. If not, then we do take our turn. Except, again, you might be noticing the slight problem we have here. Like I said, the current playable player type, this one is only set on the server, but over here this function is running on both the server and the client. So once again, let's do a simple refactor. let's make sure this function over here, which is running the logic for when we click on a grid position, since the game is meant to be server authoritative, let's make sure to run this function only on the server. So let's rename this. We can use Visual Studio, so Control RR to rename it. Clicked on grid position RPC. Let's mark this as an RPC. With send to, let's send it to just the server. And again, same thing when using the RPCs. In order to figure out the local player type, we cannot use this. We need to make sure we receive it as a parameter in order to make sure that everything works properly on the host and the clients. So up here, receive a player type, and then instead of checking this one, check this one. Again, this code right now is running just on the server. So we do this, and then at the end, obviously we change it. So let's do a switch on the current playable player type. And by default, or case.cross. If it is a cross, then the current playable player type, let's put it as the circle. And case we have the circle, let's put the current equals that one dot cross. Okay, yep, so just like this. So again, we refactored this in order to make sure this function only runs on the server. We made it receive the player type for the player that is trying to click on this grid position. Then we quickly validate again on the server. Can this player take this action? If not, then we return, so we don't do anything. But if they can't take that action, then we're going to click on that grid position and we're going to update the current playable player type. So all that's left is fixing where we are calling this function. So let's find all references. So here it is, the other one on the grid position. Over here on this one, when we click, we need to grab the local one. So let's go GameManager, the instance, get the local player type just like this. Okay, yep, so let's save and test. So over here on the server, let's take an action. We played cross, okay. Now try to take another action. And if there you go, it does not work. I am still clicking, so I am indeed capturing the clicks, but no action is being taken because this is not the player that is currently meant to be playing. If instead we go over here on the client, and over here we try to take an action, and if there you go, it does work, we play circles. And again, if the client tries to play again, so let's play a circle over there, and nope, it does not work. So again, this one is still capturing clicks, and it is sending RPCs to the server over here, but since this circle is currently not the one that is meant to be playing, because this one does not work, this is now the current active one, so now this one plays, and this one can play, then this one, and so on. Alright, awesome! Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create a player UI to show the current player, as well as who is meant to be playing in the current turn. Okay, so over here we can now place objects, so I can click on the host to play, and I can click on the client to play. And we do have turns implemented, so the client cannot take 2 actions in a row. So now that we have this, let's make a nice UI to show who exactly is the current player meant to be playing. So for that, let's set up a UI. Since it's our first time, let's go over here, create a new object, create a new UI, and let's make a brand new canvas. And if there it is, here's our canvas. So let's set it up. I'm going to use the same setup that I normally do. So over here on the canvas, everything is normal, so screen space overlay, yep, makes sense. And then over here on the canvas scaler, the way that I personally like to scale it is scale with screen size. Then for the reference resolution, I like to put it on 1920 by 1080p, and I like to fully match with the height. So basically this setup means that as we change resolutions, the anchors on the corners, those will move horizontally, but they will not scale. They will only scale if the vertical resolution changes. So for example, just for testing, let's create a brand new UI image. And let's anchor the image, let's say on the right side. Let's put it over there to see what happens to this image. So yep, we have this image over there on the right side. And now if on the canvas, since we set it up to match fully with the height, if the height of the window changes, note how that one does scale. It gets scaled down, so it always keeps that size if the vertical size matches. The only thing that changes is if we modify the aspect ratio. So we have 16 by 9, if we put it on 5 by 4, yep, there you go, it just moves slightly to the left. So basically objects move horizontally left and right, and if it changes vertically, then everything scales accordingly. Now personally, I really like this setup because it means that I can position everything that I want, and I basically only need to remember that the corners will move horizontally and nothing else. So usually I set it up exactly like this, scale with screen size and scale with the height. And then I just make sure that the game is playable in a short resolution, like 5 by 4. If the game is playable like this, then I know for a fact it won't be playable in any other resolution, like 16 by 9. Okay, great, just like this, let's delete our testing image. So now inside our canvas, let's create an empty game object. Let's name it the player UI. Then over here, let's stretch to occupy the whole thing. So we can hold down Alt as we click on this. And if there you go, everything is stretched, everything 0, 0, 0. Over here on the scene view, we can actually see what happens to that. So let's focus on the UI. Yep, there you go. It occupies the entire screen area. Now inside the player UI, let's create a new UI image. And for this image, let's use the sprite over here for our cross. Let's anchor it up top. So anchor on the top there and put it over there. let's put it slightly to the right. So let's put it on position of 50 and put it really at the top, so on minus 55. Okay, great. Let's duplicate this, put this one on minus 50, and for this one, let's put the circle. Then let's also make a background, so inside create another UI image. Let's also anchor it to the top, and by the way, here we can hold shift in order to also set the pivot. So let's hold shift, put it in there, then over here on the position, let's put it on 0. And if there it is like this, let's put it on black, and really just stretch it a little bit to the side just to make a nice background. Also, quick note, so right now the background is on top of our icons. We don't want that. Basically over here, the way that sorting order is defined in a canvas element, the way is all based on position in the hierarchy. So if we want this one, let's just rename this is the background. If we want this one to be behind the others, then this one basically needs to be on top. So let's click and drag, put it up there. So basically it's going to render this object, then this object, then this object. So if we want this one to be behind, we put it at the top of the hierarchy. Okay, so yep, we have that simple element, and this one's actually partially hiding our grid position. So let's actually just move the camera a little bit. So over here, let's put it on a Y of 0.6, so just lift it a little bit, and let's make it a little bit smaller so it actually sees things. So on the size, let's put it 6. Okay, yep, like this, and let's also just reset the background, make sure the whole thing occupies the entire view area. Okay, great. So back in our UI, let's go inside the UI, create a new text mesh pro. And yep, since it's the first time we're importing text, it shows up this window asking us to import the TMP essentials. So let's do that. Okay, that's done. For the text, let's write U. Let's put the width and height of 0, which then causes the text to be shown vertically. In order to fix that, let's put it down center, down the middle, and over here for text wrapping, put it as no warp. Yep, it says U. Let's put it in bold, and basically we want to put it over there up top. So let's anchor it to the top, and let's move it. So over here, let's move it up there. Something like this, put it on 50, then let's duplicate it, and put this one on minus 50. Let's just give these proper names. So this one is the cross image, this one is the circle image, this one is the cross U text mesh, and this one is the circle U text mesh. So here we have those elements. So this one is basically going to be enabled or disabled in order to show the current local player. Now let's just make an arrow in order to show which one is meant to be playing right now. So inside UI, let's make another image. Let's also anchor it up top. And for the image itself, for the sprite, let's use this nice little arrow, and let's position it sort of like that. On minus 150, then let's do another one on plus 150, and this one just rotate it to the other side. So yep, over here on the Z, put it on 180. Okay, yep, that's our UI setup. Let's just name this. So that's the circle arrow image and the cross arrow image. Okay, great, we have all of our elements. Now let's make the script that is going to run this. So in our scripts folder, let's create a brand new model behavior script called the player UI. Let's wait for it to compile. Let's select the player UI, attach it, and open. Okay, so now here, first of all, let's grab all of our elements. And again, let's make sure to write some good, clean code. So let's make it a serialized field, private. And the things we want to grab are going to be the game object for the cross arrow game object, another one for the circle arrow game object, and then same thing for the cross U text game object and the circle U text game object. So yep, all of these 4 elements. Over here in the editor, let's just drag the references. So the cross U text mesh, that's the cross U text. For the circle U text, then we have the circle arrow and the cross arrow. Okay, so now here, first thing is on awake, let's hide all of these elements. So all of these cross arrow game objects, set active into false to disable it. Let's hide all the elements, so just copy paste all of these. Okay, all of them are now hidden. And then we basically want to show them when we actually have a connection. We're going to update the U text whenever we connect and we know which one is the current local player. And then we also need to know when the turn changes in order to figure out which of the arrows to enable. So to figure out both those things, let's do, of course, over here some more events on our game manager. So let's define events. So the usual syntax, public event handler. Let's do one called onGameStarted. We're going to fire this event when both players have joined. So let's go down here to the onNetworkSpawn. Here we know when this object is spawned on the network. However, that is really just meant for when this object is spawned, meaning this one does not trigger twice if we connect with the host and the client. If we are the host, this one is only going to run once. Whereas instead what we want is we want to know when clients have connected to the server. So for that, the network manager actually has a really nice callback. So over here on the server, again, let's make sure to do this logic running just on the server. Let's access the network manager, access the static singleton, and inside we have this one, the on-client connected callback. So let's listen to this one. So on the network manager on client connect callback. So this basically runs whenever a client connects. And this one's basically going to be the ID of the client that connected. So when this happens, In order to fire off our on-game start event, we really just want to start the game whenever we have 2 players connecting. So that's also quite simple. So we can go Network Manager, access the static singleton, and we check this one over here, the connected clients list. Like name implies, this is a list of the connected clients. So we can check if the count equals 2. If so, then we have 2 connected clients. If so, then yep, this is where we want to start the game. So over here on game starting, let's do an invoke on this one, this event args.empty. Yep, we have this. And also, since this is when the game is actually starting, then it's actually over here that we want to set the current playable. That way, even if the server connects and is waiting for a connection, it won't actually be able to take an action until 2 players have connected. So yep, we have this nice event. And then over here on the UI, let's listen to that event. And again, following that rule, when setting up this object, we can do it on awake, but when accessing an external reference, and the game manager is an external reference, when doing that, let's do it on start. So on start, game manager, access the static instance. Let's listen to that event. On game starting, listen to that one. Rename this to game manager. So when the game starts, this is when we can check which one is the unlocal player. So game manager, the instance, get the unlocal player type. So if the unlocal player type manages the cross player, if it is, let's go on the cross U text game object, set active into true. And if not, then let's set the circle as true. Again, make sure it's the circle U, so don't make the mistake of playing with the arrows. Over here, we want to modify the U text. So if it is a cross, show the U. If it's a circle, show the other U. Okay, so yep, so just like this, that handles the U text. And then for the arrow text, over here, let's make a function to update the current arrow. So private void, update the current arrow. So over here, let's do an if on the current player type. So let's actually first expose it over here on the game manager. We want to return the current playable player type. So let's do that. So public return a player type. For the get the current playable player type, let's return the current playable player type. And then over here on the UI, game manager, the static instance, get the current playable player type. And if that one matches the cross, if so, let's go on the cross arrow game object, set active into true to enable that arrow. And for the circle arrow, let's set that one into false. So do that, then an else, and over here, same thing, but do the reverse. So this one becomes false, and this one over here becomes true. Right, yep, so over here, when the game starts, we are updating the uText objects, and then we are updating the current arrow. The other thing missing is we need to call this more than once. We need to call this when the turn changes, not just on the game starting. So once again, let's fire another event when the turn changes. So over here on the game manager, let's make another event. So public event, event handler. Let's call it on current playable player type changed. So we have this event, and let's just call it whenever that one changes. So let's see over here the current playable player type. Here is when the game is starting, and over here this is where it changes. So over here, this one dot invoke this event args.empty. Then over here on the UI, let's listen to that one. So game manager, the instance. Let's listen on the current playable type changes. Let's listen to that one. Game manager when that one changes. When that one changes, let's update the current arrow. Yep, just like this. Except, like this code actually has a bunch of issues. This will not actually work exactly as we want to. If you want, pause the video right now and try to figure out why this will not work as intended. The answer is honestly the exact same thing that we've already seen previously. So let's do a quick test to see how exactly this is working and not working. Okay, so here we are, and so far it actually starts off correct. So all the elements are currently hidden by default. That makes sense. They should only show up when we have a connection. So over here on Network Manager, let's start a host. And yep, still hidden, exactly as intended. They only show up when we actually have a connection. So on this one, let's connect with the client. And if there you go, over here on the server, we can see it did work. As soon as we have the connection, the U over here did enable. So this one is currently playing crosses, and it is currently the crosses turn. So yep, it worked. Except here we have our issue. The client does not know that happened. Then for the error logic, here if we take an action, if there you go, look how the error logic is indeed working. But again, same issue, the client does not know that happened. So here the issue we have is literally the exact same issue we've already seen many times. The issue is how this code is only running on the server, meaning only the server is actually invoking this event. And when it comes to the onClicked on grid position, that was not a problem because that one we are just spawning objects on the server. So it does not matter that this one is only fired on the server. But on the player UI, we do want this event, this one over here, we do want this one to be listened by both the client and the server. Same thing for this one, the on-game starting. Right now the client is not listening to this event, so that is why the uText does not appear. So we need to make sure both of these events are fired on both the server and the client. So the way to solve this is actually quite simple. We can use an RPC, but instead of being just a server RPC, we can use an RPC that goes to everyone. So let's define a private void, call it trigger on game starting. Make sure to append RPC in order to make it an RPC. Over here, let's use the RPC attribute and call send_to. In this case, we don't want to send just server. Instead, we want this one, clients and host. Meaning all the clients and the host, all of those will be running this function. All of those will receive this RPC. So just like this, and then on this one, we do fire off that event. So we do that, and then over here, we call this. So again, always keep in mind what code is running on the server and what code is running on the client. So over here, let's go through the entire logic. So this one, this instance, this GameManager exists on both the client and the server. And this one is a network behavior. And because that, over here, we have the on-network spawn. So this is going to run on both client and server. But then over here, we have an if is server. So this code inside of this is only going to run on the server, meaning only the server is going to receive this code. The client does not run this at all. Then the server does validation to start the game, which makes sense. Only the server should be the one responsible for that. And when the server decides that the game is ready to start, if so, the server is going to call this RPC. And this one, since it's marked as clients and host, this RPC over here, this code will run on both the server and the clients. So that way, over here, the UI, this one that is listening to this event, this should now be triggering both on the client and the host. So yep, that solves this one. And then it's over here, this one, the onCurrentPlayable. So let's do the same thing. So private void, trigger this event RPC, mark this as an RPC with send_to both clients and host. And in here, we just invoke this event. And up here, we just call trigger that RPC. So once again, this one over here is only running on the server, and then the server calls this function, and then this function runs on both the clients and the host. Okay, so that should solve the issue where the client was not updating at all. However, we still have one remaining issue, but let's test like this and see if at least over here the U signs, if these do show up on both the client and the server. So let's save all of our files and let's test. Okay, so for starters, all of them are hidden. Great. On this one, start the host, and yep, still hidden. Great. Then on this one, start the client. And if there it is, right away it's working. So we can see the U. So over here, this one, the client is playing circles. Yep, exactly. And this one over here is playing crosses. Yep, exactly. Except here's the last remaining issue that we saw. Over here, this one, the host is saying that the crosses is currently the current player type, which is correct. This is the one that can currently play. But then this one is saying that it's the circles. Now in reality, this one is not really saying that it's the circles. The only reason it's doing that is because over here in the code, on the function to update the current arrow, we're testing the current playable player type. We're testing if it's a cross. If so, we do that. And if not, we do this. And once again, it goes back to the same thing about what data lives on the server and what data lives on the client. And the current playable player type, this one is only set on the server. On the client, by default, it is set to none. And since none does not match a cross, that is why it runs this code and appears to show that it's a circle, when in reality, it's set to none. We can see over here, if we take an action, yep, that one is still stuck in there. Take an action, that one updates, but that one is still stuck. That one never updates, never changes. So yep, this is the issue. And now one possible solution could be what we did previously with the Game Visual Manager. So over here, inside the position events, we passed in the player type. So we use this one on the RPC. So technically over here, when triggering the onPlayable type change event, on this one, we could add some extra data to set what is the current playable player type. Or this is actually a great case to learn about a very, very useful feature of Netcode for game objects. Those are network variables. So let's learn all about that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about network variables. This is a really useful type from Netcode for game objects that makes it really easy to synchronize any kind of variable. Okay, so here we have both players connected, and on the UI they are correctly seeing which one they are. So this one over here, the host is playing as crosses, this one is playing as circles. So that element is indeed working correctly, but the current playable display, this one is not working correctly. On the server, it is saying that the crosses is the one playing, which is correct, but this one is saying the circles. In reality, this one is actually saying none is currently playing, which is not valid. So this indicator is not working on the client. If we take an action on the server, yep, that one updates correctly, but that one does not. That one always stays stuck in there. So we need to solve this issue. Basically, the issue is, once again, has to do with the whole thing of server versus client. Over here on the GameManager, we define the current playable player type, and we made this as just a normal local variable. We made it like that, and then this one basically only exists on the server. This one is never really assigned on the client. So the client for this type really just ends up defaulting to none and never changes. So to solve our problem, we really just need this variable to be synchronized across all the clients and not just on the server. And one way to solve it is, like I said, we could use a client RPC. So whenever we change this, whenever we modify this one over here, we could pass in a client RPC and say which one we change it to. We could do that, that would work. But if we want to synchronize some data pretty much all the time automatically, instead of manually writing some RPCs, instead of that we have a simpler approach. For that we can use network variables. Like the name implies, these are variables that are automatically synchronized across the network. They are really very easy to use. Over here, instead of just using a player type, instead let's use a network variable of type player type. So if this is a generic, the network variable can be of almost any type. There are some limitations, but you can use quite a lot of types, specifically enums, so value types. So if just like this, we made a network variable of type player type. And importantly, one very, very important thing is network variables need to be initialized exactly when they are created. So over here, when we define it, we need to initialize it. So equals a new network variable and do it just like this. Then over here, we have all kinds of parameters, all kinds of settings we can change. We can give it some kind of default value, and then we can modify the read permissions and write permissions. So for example, we can set it playertype.none. Then for the read permissions, we go inside of this enum. And inside this, we can say everyone can read or just the owner can read. And then for the write permissions, for this one, we can say the owner can write to this one or the server can write to this one. So we have all kinds of ways we can control how exactly this network variable is being synchronized. But for now, and really in most cases, we can really just leave it on defaults. And defaults will be that everyone can read, but only the server can write to it. That's exactly the level of accessibility we want, so let's go just with defaults, just like this. So yep, we made this, and by modifying the type, naturally over here we have all kinds of errors. These are very simple to solve. Instead of modifying it directly, just go inside, grab the value, and modify that one. So yep, just change that one. Then over here, when checking the player type, check that one .value. And down here, when checking the current type .value, and we modify it to that one .value like that. And then finally down here, for getting it, get that one .value. Okay, so yep, just like this, we have no more errors. And since we are now using network variables, we can actually refactor over here this RPC. So we need to do this because basically only the server was running this code. So we need to make sure we make a client RPC in order to run this event on both the clients and the server. But since we now made this a network variable, if so, network variables actually have a really awesome delegate. It is something that is called whenever they change value. And for attaching a listener to that delegate, we should do it over here on the onNetwork spawn. So let's do it. So when this object is spawned, let's attach a listener. And again, we want to listen on both the clients and the server. So let's put it not inside this is server, but outside of it. Okay. So over here, let's go current playable player type. And let's listen to this one, the on value changed. And now also for some reason, this one is not marked as an event. So if we do plus equals, we don't actually get the Visual Studio auto completion. This one is really just a normal delegate. It is not technically an event. So let's attach a listener, and the signature for this delegate is actually quite simple. We just have the type that we want, so in this case it's player type, and this is the old player type, and then we've got another player type for the new player type. So yep, this right here, this is the signature for this callback. So we've got the old value and the new value. So like I said, this one is basically going to be called whenever the value changes, and since we are attaching the listener on both the server and the clients, then over here for firing off this event, instead of using this RPC, we no longer need this code. And over here, we no longer need this. Basically, whenever the server modifies this, it is going to modify on both the server and the clients. So then the clients themselves, those are going to run this. And it's over here that we can call this. And now this event is going to be both fired on the clients and the server. Okay, so yep, that should do it. We refactored our code in order to modify this variable from being just a simple player type to being a network variable. In doing so, it will automatically be synchronized across the network. So both the server and the client should have the correct data inside this variable. So yep, let's save everything and let's test. Okay, so over here I've started the host and still nothing. Great, over here start the client. And if there you go, right away it does work. So this one, the U is correct, this one is circles, this one is crosses, and it is correct that both are currently seeing that the crosses is the one playing. So if I try playing over here on the client, naturally it doesn't work. Yep, because it is not the circles playing. So if I now play on the server, click, and if there you go, this one worked, it did spawn, it did change the current playable player type, and it also updated it over here on the client. So both them really now listening. Both of them do know that the circles is the one now meant to be playing, so now it plays the circles, and if there you go, back into the crosses, circles, and so on. Alright, awesome! So thanks to network variables, we now have some synchronized data that defines which one is the current playable player type. Meaning that on the client and the server, on both sides, we do know which player is meant to be playing on the current turn. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a simple network manager UI so we have some proper buttons for starting our game. This is super simple to do, so this is going to be a very quick lecture. Okay, so our game is already taking some nice shape. We can place some actions, we can take some turns. The logic is correct as to who can place the current turn, and the UI is correctly showing who that is. So all of that is great, but so far we've been connecting using these inspector buttons. That's a little bit annoying. So since we already have the UI set up for the player UI, let's make some proper connection buttons. So over here in the editor, let's go on the canvas, and inside the canvas, let's construct a new empty game object, name it the Network Manager UI, and same thing, let's stretch occupy the whole thing, so hold down Alt and click on this. See, yep, here it is occupying the whole thing. Now inside it, let's add two buttons, so let's add a UI over here, a button, Text Mesh Pro. Let's name this the Start Host button, and inside it for the text, let's name it Host. And for the color, let's put it in white, put it in bold, and put it quite a bit bigger. Then for the background on the button itself, over here for the color, let's put it in black. And let's put it a little bit bigger, something like this. Maybe a bit bigger, like this, okay? So that's the Start Host button. And let's duplicate this one. This one is going to be the Start Client, so Start Client button. And inside for the text, name this Client. Okay, yep, two buttons. So on the Network Manager UI, let's create a new image, and over here, let's hold down Alt and select occupy the whole thing. Let's put it in black, slightly transparent, and once again for the sorting order, make this the background, and put it above the button so it shows up below. Okay, so now let's make the script to run this. So on the scripts folder, create a new model behavior, Network Manager UI, let's wait for it to compile, let's attach it and open. Okay, so here let's add references to our buttons. So again, same thing, serialize field, private, of type button, this one inside Unity Engine.ui, for the Start Host button, and another one for the Start Client button. Save these two and let's save. Then here in the editor, drag the Start Host button and the Start Client button. And over here, let's initialize them. And again, following the simple rule for initializing this script, let's do an awake. On the Start Host button, let's go inside the onClick, let's add a listener, and let's add a delegate to it. So over here, we want to start host. And this one, like I said, super simple. Just go inside the Network Manager, access the Singleton, and inside just a function literally called Start Host. Save like this, and the other one, same thing. So on the Start Client, we've got the Start Client function. And if that's it, really basic, so then afterwards, let's just hide this UI. So make a hide function, just set game object, set active into false. And over here, whenever we start either the host or the client, we start those and we hide this element. So yep, that's it, super simple, let's save. So yep, we can now both play maximize both on the host and the client. And on this one, we have the buttons, so this one start the host, this one start client. And if there it is, our game start playing, we can now take actions and everything works perfect. Alright, awesome! So we no longer need to go through the hierarchy, we have some nice in-game buttons, and everything is working perfectly. Now, one issue we currently have is how we can actually take turns on the same position. So right now, cross is playing, and if I click this, yep, there you go, that one was a valid position, and if I click over there, yep, there you go, I can place positions on the exact same place. That is because we're not actually tracking what grid positions have what object, so that's going to be our next challenge, so let's solve that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to define a player type array so we can store the current state of our board. Okay, so our game is currently working, we can place objects and we can take turns, that's great. But we have an issue. Right now, we can place multiple turns on the exact same grid position. Obviously, that is not correct. We should not be able to take a turn on a position that is already occupied. So let's solve that, and this one is also going to be very simple. Basically, we just need to keep track of what exactly is the board state. So we need to structure some data that holds the data for each grid position, and then we really just need to check, is that grid position empty? If so, then we can place. If not, then we cannot place. So yep, over here on the GameManager script, to store our board state, let's make a simple to the array. By the way, I have a lecture on multidimensional arrays in my C# course if you want to learn more. So over here, let's define our 2D array. So private of type player type, and this one's going to be a multidimensional array, a 2D array. So let's use these square brackets with a comma to have our 2 dimensions for the player type array. So we have this, and then over here on awake, let's initialize it. So a new one. In this case, our board size is fixed. It is always going to be a 3x3 board. So if we have it, and again, because we did things properly, we defined the player type and made the 0 value, the default value, to be none, because this one is already correct. As soon as we initialize the player type array, all grid positions are currently being set to none, exactly as intended. So we have this, we have the player type array, and then let's go down here to where we are clicking on a grid position. Here we check if we can play, so if it's the current player type, okay. And then let's do another check. So let's check if the player type array on this grid position, so x, y, if this one is already occupied, meaning if this one does not match none. If so, then this one is already occupied. And if so, then we cannot take an action, so let's return. If not, then we can indeed take an action, so let's go on the player type array, this x, this y, and set it to exactly the player type that played this action. So that's really it. Super simple, just a 2D array. This one holds the grid data. And right now we should not be able to place the same turn on the same grid position. Okay, here we are, start host, start client. Then on this one, gonna place a grid position there. Then this one, try to take a turn on the same position. And nope, it does not work. This position is occupied, so it does not let me place that grid position. But if I place over there, yep, that one works. And this one placed there, nope, does not work. But this one is empty, and yep, that one does work. So just like that, we can no longer take positions on the exact same grid position. All right, awesome. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create a function to test if we have a winner. Okay, so our game is looking nice, we can take turns and we can place objects in various grid positions. However, if right now we make 3 in a row, yep, nothing happens, the game really just continues forever. So the one thing missing is checking if we do have a winner. Now, thankfully the win logic for this game, Tic-Tac-Toe, this is super basic. It is really just 3 of the same symbol in a row, and since the grid map is fixed, it's only a 3x3 grid. Because that, we only have a few possible win positions. We can have 3 horizontal lines, we can have 3 vertical lines, or 2 diagonals. So here in the code, let's go in the GameManager, and let's go ahead and make a function to test if we have a winner. So here, private void test winner. Okay, so the logic for testing is super simple. Like I said, just check 3 of the same type in a row, and see if all of them match, if all of them have the exact same player type. So for example, let's check the bottom row. So we go inside the player type array, on index 0, 0, and we check if this one, and first of all, we have to check that it's not empty, so this one is not .none, okay? So if this one is not empty, if it has something, then we check if 0, 0 equals the one on 1, 0. So we're doing the bottom horizontal line, and then we check for the last one, if 1, 0 equals the 2, 0. If so, then yep, here we have a nice win. So basically we have a winner if 3 positions are exactly the same. So let's actually make a nice helper function for this. Let's make a private bool, call it test winner line. And here we're going to receive a player type for the A player type. Then we've got a B and a C. So if we have this, and let's do the exact same thing. So let's return if the A player type does not equal none. So it does not equal none, and A player type equals the B player type, and the B player type equals the C player type. So basically the same thing we have down here, and then down here, instead of using all these indexes, we just call test winner line. Test winner line, go inside the player type array, index 0, 0. Then we do one on 1, 0 and on 2, 0. So that's it. And here, if we have winner, let's do a debug.log winner. And when we do, let's also set the current playable player type. Let's set the value equals that one dot none, so we can basically stop playing. Okay, so yep, so this is our simple test winner function. This should test the entire bottom row. And then all we need to do is just call this. So for calling this, let's just call it over here when we click on a grid position. So when we do, over here we are updating the player type array. So afterwards, let's call the test winner. And again, always remember, multiplayer, this is server authoritative. So here we need to make sure this one is only running on the server. And yep, that's already what's going to happen here. This function over here is already only running on the server. So yep, this one is also only going to run on the server. Okay, so let's test. Let's try winning on the bottom line. So put an X, put another X, and now for the final X. And if it is, we've got the X and we have the winner. All right, awesome. And the playable type should also be changed. So if I try placing, nope, doesn't work. If I try placing, nope, also doesn't work. So the game is indeed correctly finished. Okay, great. So we are correctly identifying when we have a win. Let's just add a nice visual for it. So here in the project files, inside the textures, we have this green line. So let's use this. Let's spawn this whenever we have a winning row. Let's make a game object for it. It's actually going to have the same shape as our line. So let's actually duplicate one of these lines, call it the align complete. And for the sprite, instead of this one, let's use the align green. Let's just move it roughly over there. Yep, so that's basically what we want to spawn dynamically. And we want it to show up on top of all of our objects. So for the ordinate layer, let's put it on 10. And this one is going to be spawned on the network. So let's add a network object. And then we're also going to modify the transform. We're going to position it on the correct position. So let's also add a network transform. And for this one, really just need to synchronize just over there the position XY and also the rotation, since we're going to have the diagonals. So we're going to have to modify over here the Z axis. So let's synchronize this one and the X and the Y. Okay, so yep, this is our line complete. Let's make this into a prefab. So just drag it and let's delete it from the scene. Now here in the code on the Game Visual Manager, on this one, let's first add a field for it. So for the line complete prefab, and here in the editor, let's drag the reference. So the line complete over there. Okay, so now for spawning this, first of all, we need to know whenever we have a game win. So let's go on our GameManager script and make another nice event. So we're going to have on game win. This one will be fired whenever someone wins the game. Let's also include some extra data so we know which line is the winner. So let's do a new class on game win event args and extends event args. And inside, let's add something. We basically just need to know the center grid position. And here, by the way, just a quick tip, we can add the X and Y just like we had here, so 2 ints. Or alternatively, we can actually use a built-in type, the vector2int. So this one is basically a vector2, meaning it has X and Y, but both are ints as opposed to floats, which is what you have inside the normal vector2. So vector2int for the center grid position. This is the center position where we won the game. So let's pass this one in, so this event, okay? And now down here, when we are testing for a win, yep, here's the winner. Here we have a winner. Let's just invoke this event. So let's invoke with this and with a new event args. And for the center grid position, in this case, it is position 1, 0. So let's put 1, 0. That's this position right here. Okay, yep, so just like this. So now on the Game Visual Manager, let's go Game Manager instance. And when we have a game win, let's listen to it. So listen on the Game Manager. And over here, this is where we want to instantiate. So let's instantiate the line complete prefab. For the position we want to spawn it, let's use get the grid worm position. Pass in the e.centergridposition.x, e.center.y. So we have that one, then the quaternion.identity. So yep, this one is going to spawn. So transform for the line complete transform. So we have this one, and again, we need to spawn it on network so that it spawns on all the clients. So let's get the component network object. And on network object, let's call spawn true. Okay, yep, just like this. Let's do a quick test. Okay, let's do a win. So put that one, and that one. And yep, there you go. It does spawn, and it is indeed synchronized across the network. All right, awesome. So everything is working. All we need is really just to do this test winner for all the possible cases. And now for this, of course, we have several ways we can do this. And the most obvious one is we can really just copy paste this code a ton of time and manually write all of the possible lines. Since this game actually has a fixed grid size, that wouldn't necessarily be too bad. I mean, it does have quite a lot of copy pasting, but with a little bit of refactoring, it wouldn't necessarily be too bad. But still, it would be pretty long. And like I said, I'm trying to teach you the proper way on how to write good, clean code. So even though this approach wouldn't necessarily be too terrible, let's put in a little bit of effort to make a more complex, but more proper, more dynamic way. So to do that, let's first define a simple helper type to store basically the concept of what exactly is a line. So let's go up here and define the concept of a line. And since we're just going to be storing some data that is only meant to be read-only, usually when I define something that is just a data container, usually I like to make it a struct as opposed to a class. By the way, you should really know the differences between structs and classes. I have a lecture on my C# course on structs and also one about classes, as well as the difference between value types and reference types. I highly recommend you watch those. It is very, very important to know what are structs, what are classes, what are value types, and what are reference types. So yep, over here, let's define a struct for our line. And in order to identify a line, again, remembering the original goal that we're trying to solve by defining this type, the original goal is so we don't have to do a ton of copy-paste code here. And basically, the data that we need to test a winner within a certain line, we need to know the 3 positions that make up a line, and then we need to know the center grid position that also makes up that line. So up here, let's do exactly that. Let's store a list. And again, here for this one, I'm making it public because this is just a data container. So very much the same thing as with the event args over here. These are basically the exceptions, and generally you should keep things private. But over here, for just a data container, let's make it public. Let's use a list, making a list of type vector2int, and this is the list that exists inside the systems collections generic namespace. So we have this one, that's the grid vector2int list. We have this, and then a public vector2int for the center grid position. Okay, yep, so this is our line. And then just over here, let's make a private, a list of lines. That's our line list. And then over here on awake, let's just initialize all of them. So let's do a new list, and then let's just create all of our lines. So we do a new line, and inside new line, we have a grid vector list. And that grid list, that one contains on position 0, 0. Then we also have on 1, 0 and 2, 0. Okay, yep, we have that. And then for the center grid position, in this case, that is going to be on the 1, 0. All right, so yep, so this is the bottom line. So then let's make the other horizontal ones. So we have one that starts on 1, 0, on line of 1 like this. Then we have one on 2 like this. So these are all three of our horizontal lines. So here, these are the horizontal ones. Then let's do the vertical ones. So for the vertical, that is, for example, 0, 0. Then we've got 0, 1, and finally 0, 2. And the one in the middle is going to be 0, 1. That's the first vertical one, and then the other ones. So that's a 1 over there, 1 over there, 1 over there, 1 over there, a 2 in there, 2 in there, 2 in there, and 2 in there. Okay, these are the vertical ones. And finally, we just need the diagonals. So diagonals, and we have two of them. So we have one that goes from 0, 0 onto 1, 1 onto 2, 2. And the middle is 1, 1. And the final one, that is the one that comes from the top. So on 0, 2, 1, 1, and then 2, 0. And the middle is also 1, 1. All right, yep, so here we have all possible combinations, all possible lines that we have in our code. So with all of these possible combinations, we can now go down here onto our test winner function. And over here, we can just cycle through that list. So for each line in our line list, let's cycle through all of it. And then we're just going to check if we have a winner. So let's just make another version of this helper function. So we've got a test winner line takes A, B, C, and then let's have one that takes in just a line. And then this one is going to return the test winner line, pass in the line dot the grid position on index 0, then 1 and 2. And actually, it's not quite like this. We have to go through the player type array on that one dot x, and then this one dot y. So we got 1, 2, 3. So on 1 and 2, on 1 and 2, like this. And it's actually the test winner line, like this. All right, great. So we have this one, nice helper function that takes in the line. So let's use this one. So over here, if we try to test if this one is a winner, if so, then yep, here we have a nice winner. We reset the current playable, yep, and on game win. Over here, let's also refactor this to receive a line as opposed to just a center grid position. So on the on game win event args, pass in a line. So then down here, when invoking, set the line equals this line. So we do this, and since we are inside a for each, let's make sure we have just one winner, even though we are always going to have one winner. So like this, do a break, and that's it. All right, awesome. So like this, our code is really nice and dynamic. We have all kinds of lines, but we are checking it through this nice, simple dynamic code. Then over here on the Game Visual Manager, over here we go inside the line, and the line also has a center grid position, just like this. Then we spawn it on network, and so on. Okay, that should do it. Let's save all our files, and let's test. Okay, so let's try to win in the middle. So place there, and now place there. And if there you go, it does spawn, and it does spawn on the correct position. So we do identify we have a win inside of this line, and it does spawn it correctly. However, it is not 100% correct. Let's play again, but now let's actually try to win vertically. So let's put there, and now there. And if there you go, there's the issue. So it worked. It did identify that we have a vertical win, but the line is not rotated. So over here in our line type, here we do need to know the orientation of this line. So let's define an enum to define that data. So up here, a public enum, call it orientation. And the lines, they can be either horizontal, they can be vertical, or they can be diagonal A or diagonal B. That's because those have two different rotations. And then over here, let's assign that. So orientation. So we assign that on the line, and then we just need to add to all of these. So orientation, in this case, it is horizontal. All of these are horizontal. Then these are all vertical. So let's put this like this on all three. Then these are diagonal A, and we have diagonal B. Okay, yep, that's the data. And since we are passing in a line through our event, everything's already working down there. So it's only over here on the Game Visual Manager. Over here, we need to do a switch in order to figure out the rotation we want to use. So let's do a switch on e.line.orientation, and then do a default, and do a case we have a horizontal. If so, let's define the Euler Z angles. So float Euler Z default to 0f. Okay, so if it's horizontal, then we do want a 0f equals 0f. Let's break, okay? And then we have the other possible types. So we've got vertical, we've got diagonal A, and diagonal B. So out of all these possible types, if it's horizontal, it has 0 rotation. If it is vertical, we need to rotate it 90 degrees. If it's diagonal, then either it's 45 or minus 45. Okay, yep, just like this. And then over here, when we call instantiate, so we pass in the align complete prefab, get the world position. And then over here, instead of using the quaternion.identity, let's use the quaternion dot this one, the Euler angles. This one, the Euler. Pass in 0 on the x, 0 on the y, and then on the z, let's use the Euler z. Alright, yep, just like this. So let's do a quick test and see. Okay, let's try to win vertically. So over there, and over there. And if there you go, it does win, does rotate, awesome. Now let's test the horizontal up there on the top. So like this, yep, it does work. And finally test the diagonal, so we place there. And if there you go, it does work perfectly. Alright, awesome. So here we have our win condition fully working. The game tests if we have 3 in a row. It tests for all the possible combinations of that, and when it does, it spawns a nice visual element, and we have a game win. So now that we have our win condition, now of course let's handle a proper game over screen. So let's do that in the next lecture. Hello and welcome, I'm your code monkey. In this lecture, we're going to create a game over UI to show up when the game ends. Okay, so let's build our game over UI. So let's go inside the canvas, create a new empty game object for the game over UI. Let's go up there, hold down Alt and stretch occupy the entire space, okay? And for this, we really just want some text over there in the corner saying either you win or you lose. So let's just build that, so just UI, let's make a text. Over here, say something like you win. Let's put it in bold and some big letters. Let's also make it centered down the middle and make sure we have no wrapping, so width and height both of 0. And on wrapping, put it no wrap. Okay, let's increase it a little bit more. Okay, like that, let's just make a nice background. So an image, let's put it in black. And over here, let's stretch it to occupy a big enough space. Kind of like this. And of course, let's put it behind it. Let's name this the background. And let's put it over on the corner. So let's select both objects. Let's put it roughly over there. Something like this, a little bit tilted. Like this, I think it looks pretty nice. So either you win or you lose. Okay, great. Now let's make the script to run this. So let's create a new MonoBehavior script, the game over UI. Wait for it to compile, and let's attach a script. Okay, so now here, first let's add a reference to the text. So a serialized field of private of type text mesh pro u GUI. It is this one, that's important. We're working on the UI, so it's this type. It is not this one, so it's the UGUI one. This is the result text mesh. Then let's also make 2 more fields of type color for the win color, another one for the lose color. So let's save it. Here in the editor, let's assign those. So for the text, drag that one. For the win color, let's put it a nice green. And for the lose color, let's put it some kind of red-orange. Also, by the way, very important over here on the color, make sure you set the alpha to the max, otherwise the text will be invisible. Okay, great. Now let's make some simple show and hide functions. So we've got a show, we just go in this game object, set active into true, so we're going to show it. And then on hide, we're going to do the opposite. So on hide, set this one into false. And then we have a private void start, and on start, let's begin by hiding this. Okay, that's great. So now for showing this, we really just need to listen to when the game manager wins, and we need to pass in some data for who won in order to figure out did we win or did we lose. So over here on the game manager, we already have the on game win. On the event, let's just add some extra lines. So the player type, let's pass in the win player type. And then when invoking this event, so down here, let's pass in the win player type. And here we can really just grab it from the first position on the list. So player type array, let's go inside this list. Let's get the center grid position.x and the align dot center grid position.y. So yep, that one is going to be the winning player type. All right, now here on the game over UI, let's listen to that. So game manager instance, let's listen when we have a game win. So let's listen for game manager on game win. So when we do have win, let's check, did we actually win? So let's go inside E, let's get the winning player type. And if this one matches the local one, so game manager instance, get the local player type. If so, then that means that we won. So result text mesh.text. Let's put it you win, and result text mesh.color. Let's put it for the win color. If not, then we lost. So over here, let's put you lose and put the lose color. Right, yep, like this. And of course, let's show it. So that should do it. Let's save all our files and let's test. Okay, here we are. Let's host, let's client, let's make a win. So put it there, and finally put it there. And if there you go, nice, we have a you win. All right, great. So that worked. But again, the usual problem, it did not run on the client. Once again, that's because over here, the test winner, this one is only running on the server, meaning that this event is only being triggered on the server and not on the client. So once again, let's do the same thing that we've already done previously. Let's make a nice client RPC that can invoke that event. So over here, a private void trigger on game win RPC. This one is going to be an RPC with send to clients and host. So like this, and it's inside of this that we want to spawn our event. Then of course we need this data, so let's pass in the line like this. So up here we call trigger that one and pass in this line. Okay, so yep, so like this. However, if we now save this file and we look here in the editor and nope, we have an error. It's telling us an error on this function. It's telling us don't know how to serialize GameManager line. The RPC parameter types must either implement iNetwork serialized by memcopy or iNetwork serializable. This is a very important thing. It has to do with what I was talking about in the early stages of this course, on how one of the limitations of RPC is that you can only use certain types. You can easily use default types like ints and so on, but for custom types like this line, for these we need to do a little bit more work. So over here to solve this problem, we basically have two options. So we can do what that message says. So over here on the line, we can implement the iNetwork serializable. So we can implement this interface, so implement like that and so on. Then in here, we can serialize that inside the subject. So we can go inside the serializable and we can serialize the value. We can pass in the center grid position. We can pass in the orientation and the grid vector to int list. So this is how you would normally do it. However, in this case, list is an object. It's a reference type. And this helper function that makes the serialization very simple. This one does not support reference types. It only supports non-nullable value types. So we can't directly use this serializer like this. It can be done, but just not this easily. Now for this, since we have basically a fixed list amount, for this, all the lines, they always have just 3 positions. So because that, we can just avoid using an object and just have 3 fields for all of our positions. We can do that and then serialize those fields individually. That would work. But actually, in this case, we have another simpler solution. A solution that doesn't even require implementing this interface. So we can just remove this. We can just remove this like this. So back into the original problem, how this line type, this one cannot be included over here in our RPC. But like I said, we can use basic types. We can pass in, for example, an int. So over here, instead of sending a line, we can send a line index. Since basically all the clients are going to share this class, all the clients are going to have a game manager. Because that, all clients are going to have the exact same line list. Since this one is initialized over here on awake and never changes, meaning all clients have the exact same data, all clients have the same data as the server, because that, down here, when we pass in the line list, instead of passing in the line, we can just pass in the index. Since that one is an int, it works perfectly. And then over here, we can grab the line, go inside the line list, and grab on this line index. And if like this works and we don't have any issues on the RPC. This is a great example of how you can sometimes be clever by making some assumptions of what data both the server and the client has. Sometimes you don't necessarily need to synchronize some direct data. You can just synchronize a very simple offset, and that will save you, once again, a ton of bandwidth, which will save you a ton of money. And as long as both the server and the client always have the same data, if so, then that method is usually one of the best options. So up here, let's just replace this with a simple for int I in the line list.count. Let's do an I++. And then over here, line equals the line list on this index. And over here, if we have winner, let's pass in the line on this one. So yep, just like this. Except once again, if we leave it like this, we are going to have one issue. And I'm guessing right now you've already figured it out. So this code over here, this one is going to run on the server and the clients. This is going to invoke the event. So yep, that's correct. The clients are going to listen to this event. However, again, over here for getting the win player type, for this we are accessing the player type array. And this one is only assigned on the server. All the clients have this all set to none. So if we do this, it is not going to be correct on the clients. So instead of grabbing the winning player type over here, instead let's pass it in as another parameter. So up here we can go grab the winning player type. And then here we can pass in the player type for the win player type. Pass in that one, and instead of grabbing it from the player type array, we just use it like this. Alright, yep, so that should do it. So clients and server, they should all get the same data. They should all see this event being invoked. The only important thing left is actually over here on the game visual manager. We were listening to the on game win, and it's over here that we are spawning the complete line. But again, we want to make sure we only spawn on the server because the client cannot spawn stuff. So that's actually pretty simple. Over here, just go on the network manager, get the singleton, test is server, and test if we are not the server. If not, let's just return we do not want to spawn the lines. But if we are the server, then we do want to spawn it. Okay, so yep, let's save and let's see if it works. Okay, here we have both. Let's try to win on this one. Go like that, and yep, there you go, it does work. This one says you win, and this one says you lose. The line is still spawned, the text shows up and everything, so all of it is great. Let's try the opposite. So let's try to win with the circles. Let's put it like this, and now finish. And if there you go, it does work. You win and you lose. All right, awesome. Here we have a really nice game over UI showing who exactly won what. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create the rematch logic so we can restart the game after a win. Okay, so we have the game over UI working. If we get a win, if there you go, you win, you lose, that works. But right now, if we want to play again, we have to stop and start playing. Instead of that, let's make a proper button to rematch. So let's go inside our canvas and let's go inside the game over UI. Let's create a new UI button for the rematch button, and let's put it over here at the bottom. Let's make it a little bit bigger. Let's go inside, say rematch, put it in bold, quite a bit bigger. Let's put it in white, and for the button itself, let's put it in black, make it a bit bigger like that. Okay, great, there's our simple rematch button. So let's go inside the script. Over here, let's add a field for it. So field of type button, this one over here inside Unity engine.ui. For the rematch button, like this, let's save. Here in the editor, let's drag the reference, rematch button, okay. Then here, let's do a private void awake, on the rematch button, on the onClick, let's add a listener to it. And let's call some kind of rematch function on the GameManager. So GameManager instance, call some kind of rematch function. So let's make this function. Here on the GameManager, let's go down here, public void rematch. And now here, for rematching, doing a rematch really just means a few things. First of all, we need to reset the board grid positions. So that's our player type array. Need to reset all of that back into none. Then we also need to reset the current playable player type. And then we also need to destroy all the visuals. So yep, let's do all of that. So first of all, for the board positions, let's just cycle for int x equals 0, x less than player type array, get length of dimension 0, x plus plus. Then for int y equals 0, y less than player type array, get length of 1. Yep, like this, let's go inside the player type array on x, y, and set it back into none. Okay, yep, this is going to clear the grid. Then let's set the current playable player type, set the value. Let's reset it back into the cross, or alternatively, we could add a random one. I'm actually not 100% sure what exactly are supposed to be the rules in Tic-Tac-Toe. I'm not sure if it's meant to alternate which one starts, if it's meant to be random, or if it's meant to be the last loser. Either way, let's just default to cross, then we can modify this if we want. So yep, like this. So we reset this, we reset the entire board. Then of course, another very important thing is rematch. This one is meant to run only on the server. The server is the only one where the player type array and the current playable where this one exists. So let's make this one also an RPC with a send2. This one runs just on the server. And let's rename this to rematch RPC. And over here on the rematch button, rematch RPC. Okay, yep, so this works. The last thing we need are just the visuals. So for the visuals, once again, we want things to be nicely decoupled. We don't want the logic script to know anything about visuals. So to keep them decoupled, let's make a nice little event. So over here, another public event handler. Let's go on rematch. So yep, we have this event. Down here, when we have the rematch, let's invoke this one. This event args.empty. So yep, we invoke the on rematch event. Then let's go here on the game visual manager. Let's listen to that one. So game manager instance on rematch. Let's attach this listener. So game manager. Then on this one, let's just clear off all the events. This means that we just need to keep track of them. So let's actually do it here. So private void, a list of game object for the visual game object list. And this one is a list of collections.generic. Okay, yep, like this. Then let's go on private void awake. On awake, let's initialize our list. And then whenever we instantiate something, like for example here, spawning an object, let's go into the list. Let's add that one. Let's add this one dot game object. And then also when we have the line complete, let's do the same thing. Also add this one onto the list. So then over here on this one, we can do a for each game object, visual game object in the visual game object list. And we cycle through the entire list and just call destroy on this visual game object. We do that, then visual game object list, and let's just clear our list. Okay, yep, so that should do it. So we are resetting the board, resetting the current one, resetting the visuals. And the last thing we need is over here the game over UI. After we click on rematch, we want this one to hide itself. So let's listen to the rematch. So game manager on the instance on rematch. Let's listen to this one. So game manager on rematch, and on rematch, let's hide this. Okay, great. Except again, we have the same issue as usual, which is over here on the rematch. This is only running on the server. So let's make sure this event is also fired on the client. So private void trigger on rematch. This is going to be an RPC. And this one is going to have a send to all the clients and the host. And here we invoke our event just like this. And here we call trigger on rematch. And yep, like this, everything should be working. Technically over here on the game visual manager, this one should only be destroying the visuals if it's a server, although at the same time, the server is the only one that is going to spawn the visuals. So on the client, even if the client listens to this, this list will be empty. But still, if we want to be safe, we can just do a check if it is a server. So if it is not the server, then don't bother destroying. If it is a server, then do destroy the visuals. Okay, so after all this, everything should be working. Let's do a test. Just over here, I forgot to add RPC on this one. Okay, let's test. Okay, so let's do a quick win, something like that. Win. Okay, great. So you win, you lose, and we have the rematch. Let's try a rematch on the server. And if there you go, it does run. Everything got reset. So it is back to being cross and everything is empty. Let's try placing the position on the same position. And if there you go, it does work. So it is resetting correctly. Now let's try doing a rematch over here on the client. Let's make sure that the rematch logic is running properly on the server. Click on it. And if there you go, it does seem to work. The board was cleared and we are back into being crossed. So this one is not the turn. It is this one. We can do that and everything is now working. So we can do win again, rematch, play again, and so on. All right, awesome. So we can now play, win, and keep on playing. The one missing thing we have right here is this. Yep, this is the other possible win state. We can either win or lose or get a tie. Right now our game is stuck. So let's figure out a way to handle a proper tie. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to handle a simple tie condition. So we're going to verify, did the game end in a tie, and if so, show up the game over screen so we can do another rematch. Okay, so here we have our game, and we are correctly testing for a winner. Yep, there you go, we have a win. But of course, this game over here, this one can also end in a tie. So if we go like this, yep, there you go, we have a tie, and the game is now broken, we can't do anything else. So let's make sure we identify this, and when we do, let's pop out the rematch button. Now, thankfully, this is actually pretty simple. We basically have a tie when the entire board is occupied, and we still have no winner. So let's go here on the game manager, and let's scroll down to the test winner function. So here we are. So we check if we have a winner, and afterwards, let's check, do we have a tie? So here, like I said, let's just cycle through the entire board and look for the none slot. So for int x equals 0, x less than the player type array, get length on dimension 0, do an x++, then same thing for the y. So int y equals 0, y less than the player type array, get length of 1. So yep, we are cycling through the entire grid map. And now here check if the player type array on xy, on this position, if this one matches player type.none. If so, then that means we don't have a tie. We have at least one empty place. So let's define before a bool has tie. Let's default it to true. And over here, if there is a none, that means we have no tie. So has tie equals false. Let's do this and let's also break since it doesn't matter. And then afterwards we can check has tie. If so, then we do have a tie. So basically it starts off as true by default, cycles through the whole thing. If it goes through the whole thing and doesn't find a single one as none, then this one is true, so we have a tie. Whereas if we do find an empty spot, if so, then has tie is false, so we don't have a tie. Okay, yep, just like this. Let's just make a simple event to figure out when do we have a tie. So we've got on game start, on game win, on rematch. Let's also do on game tied. So we have that event, and over here, let's invoke that event. So just this event args.empty. Something like this. And now we want to show the UI when this happens. But again, the test winner, this one is only running on the server. So just like we did this, we did a separate function to trigger that one. So let's do the exact same thing. So do a private void, trigger the on game tied event. And this one, let's basically call that function. So right here, the on game tied, run that one here. So this is what we want. Let's just make this an RPC. So RPC with a send to, let's send to everyone, just like this. And up here, we call that one instead of invoking that one. Okay, great. So now we can go over here on the game over UI. Let's listen to that one. So GameManager, the instance on the game tied. So when we have a tie, when we do, let's listen to this event. And when it does, let's show this. And then for the text itself, let us say tied or just tie. And then let's put some kind of tie color. So here, let's add a tie color like this. And then we show it. If that's it, pretty simple, pretty basic. Let's just assign the tie color. So over here inside the canvas, let's go on the game over UI and let's assign a tie color. Let's put it something like a gray, something like this. And again, make sure you select the alpha. Also here on the test winner function, if we do find a winner instead of break, let's do a return. Just in case we do have a winner, we don't want to check for a tie. Okay, like this, let's test. Okay, so here we are. Let's try to get some kind of a tie. So let's try to block all the positions and make sure we don't win. And there you go, like that. And if there it is, we have a tie and our rematch button. So both them tied, and on either of them, if we click on rematch, if there you go, it does run. Now it's back to that one, back into playing crosses, that one, and we can now win. And yep, the win also still works. Right, awesome. So super basic, and here we implement a nice time mechanic. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to keep track of the total score for each player across multiple games. Okay, so right here, we're already testing for a win, a tie, and a rematch. Some of that works great, but let's also keep track of score so we know which player has won how many times. But again, remember how we have a multiplayer game. And once again, remember the same thing. If we want all clients to have access to some data, we need to do it properly. And all clients are meant to be seeing the exact same score. So once again, when keeping that in mind, if we go up here and we define just a private int for the player cross score, another one for the player circle score, if we do it, then this one is really only going to be local to the server. So the server will increase this, but the clients will keep just a 0 forever on this. And again, one possible solution is to use a client RPC to increment each one of these. That would work. But if we want to synchronize some data all the time, which for this we want the score to always be synchronized, very much exactly like we did here for the current playable player type. So once again, let's do the same thing. Let's use a network variable, except in this case, instead of being of type player type, it's of type int. So let's make a network variable of type int, and another one a network variable also of type int. And as usual, with network variables, we have to initialize them. So over here, let's initialize just default works. So just default, just like this. Okay, yep, pretty simple. So now let's go to where we are testing for a winner. So here it is, test winner, which again, this function is running just on the server. So this one checks if we have a winner, and yep, this player, this one is the one that won. So let's grab this, let's define the player type for the win player type, and it's this one. So let's pass that one into the RPC, and let's also basically increment this. So let's do a switch on the win player type. In case we have the crosses wins, so the cross wins, in case this, then let's go player cross score dot value plus plus, let's increase it. And if it's a circle, let's do the other one. So on the circle, let's do the player circle score, increase the value by 1. And yep, again, since we are using some nice network variables, it will automatically be synchronized across all the clients. So let's do it just like this. Now let's set up the UI to display it. So over here, let's go inside the canvas. Let's find our player UI. Okay, there it is. And inside it, let's create a brand new UI. Let's make a text object called the player cross score text mesh. Let's put some kind of number. Let's put it in bold. Let's put it quite a bit in there. Make sure the width and height are both 0. Put it down the center with no overflow. So the usual setup. Let's just make it quite a bit bigger. So let's make it something like this, sort of on the corner right there. So this is one, and then we have the other one over there. So this one is the cross circle, the score text mesh, and the other one is the cross. And let's also obviously just increase the size in the background just a little bit like that. Then instead of the whole thing being white, instead of that, let's just use some nice colors. So on this one, let's tint this in a nice sort of green. And then on the circle score for this one, let's tint it in a sort of blue. Okay, yep, like this. All right, so we have our two. Let's add references on the player UI. So over here on the player UI, same thing, make a serialized field, private, of type text mesh pro GUI. Always remember it's this one. It's not this one. This is the world. This is the UI one. For the player cross score text mesh. Another one for the circle score, like this. Okay, so we have these two. And over here on awake, we can actually start off with them hidden. So let's set the text and let's set it to nothing on both of them. Okay, and then we're already listening to when the game starts. So over here, we can set it to 0. And then we need to know when we have a winner. So let's go GameManager on the instance, on the game win. When we have a win, let's listen to this event. And up here, let's update the text. So that means we need to ask the GameManager in order to get both of these values. But once again, we want to write some good clean code, meaning we don't want the UI element to know anything about netcode or network variables or anything like that. We really just want to get some raw numbers. We really just want to get these two scores. So over here, let's go down to the bottom and make a nice function. So public. And now here's an interesting one. We want to return two separate scores. So you could make a public int, get the cross score. We could do this and then have a separate function to get the circle score. That would work. However, another interesting approach, something else we can do for basically getting two returned values out of a function instead of just one. For that, let's make this return void, and instead of this, call it getScores, plural. And over here, for returning things, we can use the output parameter. So I can make an outInt player cross score, outInt player circle score. Yep, just like this. This is how we define multiple output parameters. If you don't know about this keyword, then I have a lecture on it in my C# course. This is a really awesome C# feature. Basically, it allows you to return multiple pieces of data from a single function, as opposed to normally where you just have a single return type. This way, we're going to return two pieces of data. So the way we do is just set the player cross score, set that one equals. Let's get the player cross score, the network variable. So let's go through this and grab the value on that one. So grab the value, and same thing for the circle one, just like that. So grabbing the variable for the network variables, grabbing that value, and then setting it to this output parameter. So whatever calls this function is going to get that data back. So over here on the player UI, let's do exactly that. GameManager, let's go inside the instance and call getScores with an outInt, then define our variable. So player cross score, outInt player circle score. So yep, this is how we're going to return these two pieces of data. And then on this, it's quite simple. Let's just go on the text, and over here, let's just assign those. So the player cross score dot toString and the player circle score dot toString. All right, yep, just like this. Let's do a quick test. Let's just make sure to actually drag the references. Okay, let's test. Okay, so let's connect. And if there you go, on game start, everything starts off at 0. Makes sense. Now let's try to win with this one. Let's go and click. And if there you go, you win and we have a 1. All right, awesome. It did work. Great. Although in reality, it actually looks like it didn't quite work. Over here on the server, it did work. We have 1. But over there on the client, look at that, we have a 0. And now if we try to do a rematch, and let's say now we win with the client. So let's try to win with the client, and we go there. And look at that, look at what happened. Now it updated that one, but it is still behind on that one. So in reality, it is working, it's just one behind. So this is actually another great teaching moment on how some multiplayer code has a delay, since again, multiplayer, so it has to go through the network. If this was on local, then this would be working great right now. However, since it's across the network, because that if we update the UI instantly, the network variable might not actually have received that new value just yet. Basically, we set it to update on this event, on the onGameWin event, and over here on the GameManager, where we are invoking that event. So over here, the onGameWin on this one, on the trigger onGameWin, which yep, we are triggering here. And here, technically, we are updating the network variables just before the event, but again, it's the same thing that I said. In multiplayer, some things have some delay. So we should not assume that this one has been changed by the time this one is sent. It may or may not be. So we should not assume this code runs instantly if we want to update something when a network variable changes. If so, then the proper way is to have that logic attached to the onValueChange delegate, just like we saw. That way we are guaranteed to make sure it updates only when network variable actually updates. So quite simple, let's just go up here and let's make another event. So public event handler onScoreChange event. Okay, we have this one. And then let's go to our onNetwork spawn. And over here, let's attach some listeners. So for the player cross score, this one, let's go on the onValueChanged, and let's add 1. So int for the previous score and int for the new score. We don't really need these values right now. Over here, we really just invoke the event, this event args.empty. Same like this, same thing for the other one, for the player circle score. So we have this one, and this one. So yep, now we are guaranteed that this event will only be fired when the actual value has already changed. So back in the UI, let's listen to that one instead. So GameManager instance on the score changed event. Listen to this event right here. So GameManager. And when you do, then it's on this one. Then we actually want to run this code and not on that one. So we no longer need to listen to the onGameWin event. Okay, yep, like this. Let's test and see if the scores are now being updated correctly. Okay, so for stars, both at 0. Let's try to win in that one. Win. And if there you go, there's 1. That one got a 1. That one has 1. Now let's rematch. Now let's try to win on that one down there. And we win. And yep, there you go. 1-1. Everything works perfectly. All right, awesome. So we have implemented a nice score counter, and it is correctly being synchronized across the network. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add some nice and simple sound effects and music. Okay, so our game is not looking nice. Everything works exactly as intended, but one thing it is lacking right now is just normal sound effects and music, so let's make those. Our game is quite simple, so we don't really need anything too complex, meaning we don't need something with multiple mixers, multiple listeners, and so on. All we need is really just some super basic audio. So to that, let's go on the hierarchy, create a new empty game object. Call this the place sound effect, so place SFX. This is basically going to be the sound when we place an object on the board. So let's add a component, and for audio, let's add this one, the audio source. Then we can assign an audio resource. So included in the assets we downloaded quite a while ago, here we have the sounds folder, and here we have a sound for placing an object. So let's drag that one over there. Then all these settings make sense, so let's make sure that we do have play on awake. We are basically going to spawn this prefab, and we want it to play the sound as soon as it spawns. Let's make sure loop is disabled. This one is only meant to run once. And over here on the spatial blend, let's push it all the way to the left. Just make sure this is a nice 2D sound. Okay, so yep, that's it. Super basic. Now let's go ahead and make this a prefab. So just drag it on our prefabs folder. Let's delete it from the scene, and that's really it. So now when we place an object, we really just want to spawn this prefab, and that will automatically play that sound. But once again, let's write some good clean code. Meaning we don't want the game manager or even the game visual manager. We don't want either of those to handle any sounds. So let's make a proper separate script. Let's make a new model behavior for the sound manager. Let's do this, wait for it to compile. Now let's make the game object to run this. So an empty game object for the sound manager. Let's attach our script, reset transform, and open. Okay, so just like this, let's see. Let's begin by adding a serialized field, private transform for the place sound effect prefab. Then here in the editor, let's drag the reference. Okay, so now here for spawning the sounds, basically we have two possible options. So we can make it only handled on the server, meaning the server is actually going to spawn these objects and they're automatically going to be synchronized across on the clients. That's one option. Or alternatively, we can just make it local, meaning without any networking at all. Both those methods work perfectly fine. Here on the game manager script, let's just make an event that is fired whenever an object is placed. So on placed object, then down here, let's see when we place. So it's over here when we are clicking on a grid position. If we assign it, that means we place something. So let's invoke this one with this event args.empty. Except of course, like I said, we have two options over here. Remember how this code was running on the server. So here we have just a server event. Like I said, that's a valid option. So over here on the sound manager, we could listen to that event, then spawn this one. Make sure that the spawn object is a network object so that we can spawn it on the network. In doing so, it would automatically spawn on all the clients. Then we would have this one also trigger a destruction just on the server. And again, the whole thing would be automatically synchronized. So that's one option, basically synchronize all the sounds. Although alternatively, we can all do it locally. Let's do it that just so we can see a different approach. Meaning, just like this one is not going to be a network prefab at all. This one is just a normal object, so we're going to spawn it just locally and then destroy it just locally. Over here on the game manager, let's just make sure the client does see this event. So a private void, trigger on placed object RPC. So we have it inside, we are going to invoke this event, and over here we are going to call that RPC and make this one an RPC with a send to clients and the host. Okay, great, we have this one. And then on the sound manager, let's make a start. As always, a start because we are accessing an external reference. And on this one, on the object placed, let's listen into this event. So game manager on placed object. And on this one, quite simple. Let's just spawn that one. So instantiate the place SFX prefab. So we're going to spawn it. So transform for SFX transform. So we spawn that one. And then let's call destroy. Let's destroy this one, .game object. Again, make sure you select the game object because we cannot destroy a transform directly. It has to be just a game object. And then this destroy function, this is the mono behavior one. This has a second version that takes in a float for the time to destroy this object. So yep, this way we have some cleanup automatically. Let's just go ahead and destroy the sound, let's say after 5 seconds. So yep, that's it. Again, here we went with the option of having no network data. This one is just instantiating locally and destroying locally. Here we are not going through the network object and calling spawn on network. Like I mentioned a while ago, one thing about multiplayer games is how bandwidth usually has a cost. So if you can avoid synchronizing some data, if so, that will usually be the best approach. Always synchronize as little data as you need and no more. So yep, just like this, it should already be working, so let's save all our files. And now let's test, and over here on the windows we also have buttons to mute or unmute sound. Although the client one, for some reason that button doesn't seem to work. I trigger to mute and it just unmutes itself. I don't know if it's a bug with multiplayer play mode, I'm not entirely sure. But either way, let's just make sure to mute one of them, so let's mute the editor, just so we don't see two sounds. Okay, this one is the host, this one is the client, and if I try placing an object on either side, so I'm going to place an object on the host, and if there you go, it did indeed trigger the sound. Now I place an object over here on this one, and if there you go, once again, also trigger the nice sound. So I can play, I can take actions wherever I want, and yep, everything works perfect. Alright, awesome! So yep, as you can see, it's this simple to add some nice sound effects to our game. Just use an event, listen to that event, and spawn some kind of object. So that's it, pretty basic. Now all we need is really just to apply all of our various sound effects. So here in the assets we imported in the very beginning, I made a few of them. So we have the placing object, great. Then we have a win and a lose. And finally we have the music that we're going to handle in a bit. But now let's do the win and the lose. So for that, let's go on the GameManager instance on GameWin. So we can listen to this one over here. So GameManager on GameWin. And when we have a win, let's actually add up here both them. So the win SFX prefab and then the lose SFX prefab. We have those two, and then over here, this one is triggered when the game wins, but that doesn't necessarily mean when this one wins. That's just when there's a winner for the game. So we need to verify, did we win on this side or the other side? So we can just check the game manager, the instance, get the local player type. If that one matches the winning player type, if so, we have a win. So let's do the exact same thing. Let's spawn that one. In this case, spawn the win SFX prefab. Then we destroy it, and if not, then we have a loss. So let's play the lose SFX prefab just like this. Yep, that's it, pretty basic. Here in the editor, we just need to make those prefabs. So let's go to our place SFX, duplicate it, make the win SFX and the lose SFX, and really just change over here the audio resource. So this one is the lose, and this one is going to be the win. And now we can go on the sound manager and drag the references to both these, both the win and the lose sound effects. Okay, great, so let's test. Okay, here we are. And again, the sound is muted on the main window and it's only on this one. So let's see the lose first. So let's make sure this one loses. So let's win over here on this side. So let's go, and as I win, if there you go, you'll lose, and we have the nice sound effect. Now let's see the win. So let's rematch. Let's make sure we win down here. So let's place that one down, and now as we win, if there it is, we have our really nice sound effect. Alright, awesome. So we now have all three of our sound effects. Finally, let's just handle the music. And this one is also super simple. Let's just create a new empty game object, call the music, then let's reset the transform, let's add an audio source component. Over here, let's just drag the music over here, this one. Let's set it to play on awake, let's set it to 2D spatial blend, and over here on loop, let's make sure that we do want to loop this. And if that's really it, super simple. We just have this object exists, so as soon as the game starts playing, it is going to start playing some music. So if we play, and if there it is, we have some music playing right now. Alright, awesome! Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add two Unity tools to our game, Lobby and Relay, as well as talk about some other multiplayer tools. Okay, so our game is basically done. We can take actions, different players can do different things, and everything is nice and synchronized. Now for multiplayer, you probably want to implement two tools. You want to implement Lobby and Relay. I have dedicated tutorials on both these tools. On Lobby, this one is how you can group your players together before the game, so they all join together in the lobby before actually starting the connection. And then Relay, this is how you can connect those players through a Relay server in order to bypass firewalls and NAT. These are two very important, very useful services that pretty much any kind of game would benefit from. Those two exist as packages in the package manager, so we've got Lobby, and then down here we have our Relay package. They're also part of Unity Gaming Services. To manage those, you need to create a project on the dashboard. So let's go into Edit, then go down into Project Settings, and then over here scroll down into the Services tab. And if when you created this project, this Unity project, if when you created that, you also connected it to the Unity Cloud, that's a checkbox that is usually automatically ticked. If so, then you should have this already set up. It should have already created a project on the dashboard with the same name as this project. If not, you can just click on the button to create a brand new project. Then with the project created, you can use any of the Unity Gaming Services tools. Over here, I have implemented Lobby just like I did in my tutorial. I'll literally grab the code from that tutorial and paste it here. There's a Unity package with just that Lobby, or as always, the project files for this lecture, those will have that project with the Lobby and the Relay included. So yep, here's what I implemented. And like I said, all of this was built step by step in that tutorial. So here we have a nice working lobby. For starters, we just have to authenticate with some kind of player name. Now, usually this sort of thing is automatic. Over here, I just made this manual step just because if you try to authenticate with the exact same name on two separate windows, if so, you're going to have some errors. So just for testing, I made this editable, so we can authenticate with one name here, and then over here, let's use a different name. This way we can authenticate, and yep, both them run. Okay, great. Then yep, here we have our lobby. So right away we have a lobby list. So this one shows all the active lobbies, and right now there are none. Then we have a button for refreshing this page, and again, right now there's none. Another button to create a brand new lobby. So when we do, then we have all kinds of options. So we can set the lobby name, we can set it to public or private, set the number of players, and select the game mode. Again, in our game right now, Tic-Tac-Toe, this one doesn't really have a game mode. Like I said, I really just copy-pasted the project files from that tutorial straight onto here. So in a future lecture, during the polish stage, I will refactor this in order to remove basically all the things that we don't need. We're not going to need the player count, and we're not going to need the game mode. But still, like this, let's go ahead and create. And if there you go, this one now created a brand new lobby. So here we have our name. That is the lobby name, it has one of two players, and that game mode, and so on. And then down here on the other one, let's refresh. And when we refresh, yep, we can see our lobby, so the my lobby. So let's go ahead and join this one. And join, now we have two players. And yep, as soon as that one gets two players, that one automatically loads the other scene and starts the connection. Same thing for this one, that one does join, starts the connection. And yep, now the game is indeed playing. So we can now take actions, and yep, everything else works exactly the same. Alright, awesome. So yep, that's lobby right there. The players join together in the lobby, and then after the lobby has two players, it automatically starts the game, starts the connection, and everything starts playing, and then everything works exactly the same as we've seen previously. So here's the code that makes all of it work. The main thing is really here on the lobby manager. This one has all the code for interacting with the lobby service. Again, I wrote all of this from scratch in the lobby tutorial video. Basically, we've got the authentication, then we've got a function to refresh the lobby list. We've got the heartbeat, this is what we need in order to keep the lobby alive. Then the in-lobby polling. Basically, the way the service works is you constantly have to grab the lobby. Remember how lobby is not a real-time connection. It is basically just an HTTP connection. So you ask the in-lobby server for something, and then it gives you some data back. That is why we constantly have to poll, constantly have to grab the latest lobby data. So we constantly do that, and then we have all kinds of functions to get the lobby that we have currently joined, check if we are the lobby host, is this player in the lobby, get the player, including the player data. Then here's some data, change game mode, so update a bunch of data inside the lobby, create a lobby, refresh the lobby list, and a bunch more. So yep, all kinds of functions for making it work with the lobby. And then the other very important tool that I also implement here is Relay. Again, I also made a dedicated tutorial on that tool. The thing that Relay helps us do is basically bypass firewalls. So basically, so far we've been calling that start client or start host function on the network manager. And if we select the network manager, if we go down into transport, over here we can see, yep, this is the address we are connecting to and the port we are connecting to. If we want to manually allow the user to select the IP of the server, you would make some kind of input text field in your game, then you would assign this address, you would use whatever port you want, and this is how you would actually set up the connection. That's how you connect to a direct IP. However, in doing so, in order for players to actually be a host on their own IP, in order for that to work, they basically need to make sure they open their ports on the firewall. If they don't, then it simply won't work. The connection will not go through. This is a very, very common issue with multiplayer games that are player hosted. Since you have to open a port, and most players don't know how to do that, that is a very tricky issue. So that's exactly why Relay exists. The Relay is essentially just a server that exists on the internet, and that server is easily accessible, so that server does have the ports open. And then the Relay basically just acts like a middleman between the host and the other players. Since all the players can connect with the Relay, because again, it is accessible on the internet, it has all the ports open, because that all players can connect to it, and as soon as the players connect to the Relay server, then it basically opens the connection back and forth, so then the Relay can connect back into the players. All the Relay is doing is really just sending messages back and forth, so it's really just a middleman, just an easily accessible middleman. Now naturally, this does lead to a higher ping, since the connection basically has to go through the Relay server and go back to wherever it's going to. It has that downside, but it means it has no problems connecting. So you don't have to ask your players to do any kind of port forwarding or disable their firewall. So you should definitely implement Relay in your games, assuming you're not using dedicated servers. So over here in the game, I have implemented Relay. Again, I also have a dedicated tutorial on that topic. This one is really simple. To do that, just over here on the Unity transport, changing the protocol type from Unity to Relay Unity transport. And then over here in the code, there's this start game manager. This one listens to when the lobby host, when that one is meant to start the game, and is going to create the relay. And again, same thing, it's really just going to interact with Unity Gaming Services. It is going to create an allocation, get a join code, and then set up the relay server data on the Unity transport, and then start the host, which is really just going to do this, so start host on Network Manager. And then on the other side, for joining a relay, it just takes a join code, so that's the same join code that this one over here allocates. The clients just use that exact same join code, and that is basically the same thing as selecting what IP to join to, except instead of using IPs, we just use a join code that the relay knows to. So based on that join code, the relay does know which two players to connect to one another. So the relay just does that, it just sets the relay server data, then calls start client, literally the same thing, and that way the connection will be set up through the relay. So yep, here is the game with both lobby and relay working. So let's authenticate with different names just so we can do for testing. So authenticate. Here we have the lobby, so we can create a brand new lobby. And then on this one, we can refresh, we see the lobby, we join the lobby. As soon as that one sees two players join, it automatically starts the connection. So it goes onto the relay, here we can see the logs. So that one is currently going onto the relay, trying to find what is the best server that it can. Then allocates a relay, gets a relay join code. And then over here on the client, that one sees the relay join code, connects using that one, and then both of them connect. Both of them are in the same game, so we can now play. And we are playing through the relay, and we set up the connection using lobby. So yep, here's our game working really nice, and just like this, we don't need to worry about port forwarding, forwards, anything like that. The players use the lobby to find an opponent, then just easily start playing no matter what their networking setup. Now, there are a bunch more bonus multiplayer tools you can use if you want to. I covered basically an overview of all of them on this video. So over here, we're already using Netcode for game objects. That is the way we are networking data. Then alternatively, we have Netcode for entities. That's a different networking toolstack. That one is quite a bit more complex, but also a little bit more capable. Then here we are already using relay, so this is how we can connect players behind firewalls in NAT. If instead of using player hosts, we want to use dedicated servers, we would have to use this service, the game server hosting. This way we can host and manage a dedicated server fleet. If we did also use that one, and if we had a game that required it, then we also have Matchmaker. This one matches players together based on rules. And over here we are using Lobby, so we're using Lobby to group players together. Another service we could implement is Vvox. This one helps you add easy voice and text chat. Then if you do use Vvox, you probably want to use Safe Voice. This one uses some machine learning in order to identify voice toxicity in the game. All of these servers basically require authentication, so these require some kind of unique ID. Somewhat related to multiplayer is a friends list, so you can set up a friends list and the friends can connect to one another. Unity also has a leaderboard, so this one can also be fun. And any game, multiplayer or not, always benefits from analytics. So yep, Unity has all these tools and a bunch more. All of them can help all kinds of different problems in your game. But in our case, for our simple multiplayer game, using Netcode for game objects for networking, using Relay to bypass firewalls and NAT, and using Lobby to group players together, this simple tool stack is really awesome, really capable, and our game is easily playable by anyone we want. So yep, here we have our game working, everything works, we have a connection, everything is perfect, and everything is awesome. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to look at a bunch of things that I did to polish our game. Okay, so we have finally reached the polish stage. Now, polish is something you should always add to your games. You should not neglect this very, very important stage. Polish is what takes a game from great to awesome. So here, let's look at some things that I did. Now, for this I used a bunch of third-party tools to polish the game. One excellent one that I use is called Feel. This is a really awesome asset. I made a nested review on this one. I highly recommend, really awesome. Another great one that I also use is the all-in-one sprite shader. It's a great asset if you have sprites of any kind in your game. This is another absolutely excellent asset for any 2D game. I also have a dedicated review on this one. And I also use the text animator, another great asset, super easy to add polish to your text. So yep, these tools really helped me polish the game quite a lot. But because these are third-party tools, that means that I cannot include them in the project files. I'm not allowed to distribute them since I didn't make them myself. So the final project files you can download are right before this stage. I use those tools to add some really nice animations and effects all over the place. Like for example, right away you can see the background. So for that one, instead of being a static image, I added some nice little particle effects. Then when placing an object, yep, there you go, a nice animation. So there's a little shake, there's a little glow, and so on. There's one for the cross and also one for the circle. Next, when getting some kind of wind, so placing on the objects, yep, there you go with the wind, and there's the nice you win over there. The text is nice and animated, just a little wiggle. So it's a simple thing, but it looks quite nice. And here is the whole game, very playable with a bunch of things. For setting these up was quite easy. So for example, let's go inside the cross prefab. Over here we have the main game object, network transform, network component. And then inside I just had this one, the feedbacks. This is the one that is based on feel. This is the one from the feel asset. And over here just had a squash and stretch. This one is set to play as soon as this object is instantiated, so we don't need anything else. And then after it finishes, then simply disables this one so it doesn't repeat the effect. So basically just plays once, looks really nice. Then over here on the sprite, over here I'm using the all-in-one sprite shader. This one has all kinds of effects you can add to your sprites. So you have this sprite material with all of these effects, and you can play around all of these. And basically the main thing I did was add this nice little outline. So here there are some sliders so I can make it more or less intense. So basically when it spawns, starts off really intense and then goes down. I added this nice little outline as well as this simple blur effect. For controlling these, for that I use just a simple normal animation. So over here on the animation we can see if there goes sounds like this and then goes like that. Very simple. Then for particle effects on top, I also grabbed an asset for doing that. And yep, this one really just has a bunch of nice particle effects. So I just spawned one on the cross and a different one on the circle. Then for the text animator, just over there on the game over UI on this text, over here I just implement the text animator. Yep, that's it. And then over here just on behavior, just set it to wiggle. And by default, that makes those things really wiggle just like that. Then I also use a UI pack in order to have some really nice buttons. So the rematch button and one up top over there. Just some slight changes to make it look quite a bit better, as opposed to having just some normal black squares. Then of course, when it comes to polish, also means adding all kinds of post-processing effects. So I really just added this one, just added some simple bloom just so that the cross is low. And then a simple vignette. This one really just darkens the corners over there, which is a subtle effect, but I think always looks quite nice. Then over here on the lobby, I just removed all the unnecessary elements, so the things about characters and game modes and so on. So here it's super basic, really just has the lobby name, you can inspect it in lobby name, you can set it public and private and so on, so really just the absolute basics. So just create, there you go, there's my nice username, so on the other side, I'm going to go ahead and join it. And yep, as soon as this one gets to, then it also has a nice connecting window. It is starting the connection, once again going through relay, and once it finishes connecting, yep, there you go, that window hides itself and now we can play and everything works as normal. For that connecting UI, it is literally this simple. It is just a static message animated with text animator, then just listen to when the game starts and when it does just hides this element. So yep, just a few changes to make the game feel quite a bit more polished, quite a bit more nice to play. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to take a look at our final polished game. Alright, so let's look at the final game. So we start off on an authentication window. By the way, this one I left it here just for testing. Technically in the final game, you don't even need this. You would just authenticate the player right away with whatever name they have. Over here I just left it because if we authenticate with the exact same name whilst testing on the exact same PC, if so, then we're going to have issues. So just for testing, I left this just so we can use a different name, anything you want. And as long as the names are different, then we can authenticate, and yep, everything works. So here we are inside the lobby. Then here we can either refresh the lobby list or create a brand new one. So let's create a brand new public lobby. And yep, there it is, we are inside this lobby, waiting for another player to join so we can start the game. Then on this side, we can refresh the lobby list. There it is, so we can go ahead and just click on it. And as soon as we do, yep, that one joins the lobby. Now this one, as soon as it sees, yep, it starts the connection. And again, the connection, that one is implemented using Unity Relay. So we are indeed bypassing firewalls, NAT, and so on, so our players have no problems connecting to one another. And yep, once the connection is successful, then the game is now perfectly ready to play. We have some nice music playing in the background, so the game has music and sound effects. Then over here we can see our board with our 9 grid positions. Up top on the UI we can see both the score for each player, and we can see which player we are currently controlling. So over here on this window we are controlling the crosses, and down here on this one we are controlling the circles. And then we have a nice arrow telling us that it's currently the crosses turn. So over here on the circles, if I try playing, nope, that doesn't work, that doesn't do anything. But over here on the crosses, I'm going to place a position, going to click on there, and if there you go, it does work, does place my position, and of course the whole thing is networked, so the whole thing is instantiated also on the client. Now it's the circle turn, so over here I can click, place it, and if there you go, then I can keep playing. And as I finally place an object that leads to a win, when I click, if there you go, you win, we have a nice win. So this one over here has a you win message, and this one down here has a you lose message. Then we can see the score is also being tracked, so the score is currently 1-0 for the crosses. And we can then rematch and start playing all over again, take all kinds of measures, and if there you go, win again, lose again, rematch, and so on. So yep, this is the game, and despite being a relatively simple game, despite that, this one actually taught us quite a lot about netcode for game objects, about how to make multiplayer games. So first of all, we are using the network manager, so that is the main class inside netcode for game objects. That is the main class that syncs all of our data, all of our gameplay. We handle the connection, we use some RPCs to run logic on either the server or the clients. Then we use network variables, like over here for the scores, for keeping track of that data and keeping it synchronized always. Then we also added some logic for keeping track of which is the connected player, so we know this one is crosses, this one is circles. We use the client ID in order to figure that out. And then of course all the other normal logic, so the logic for clicking on a certain position, logic for spawning objects and spawning them on network, We built all of that from scratch directly over here inside this course. So yep, here it is, a really nice, really simple multiplayer game. Now if you're following along with the premium version, then I highly recommend you now go through the companion package once again. Go through all the quizzes, all the FAQs to see if you still get all of them right. Again, remember, learning is all about repetition. So if you now go back to the very first lecture and do those questions, if you do and you get them right, then you do know that you are truly learning. Remember how you only truly learn by doing, by putting into practice. So do take some time right now to actively test your knowledge to ensure you have really learned all the contents in this entire course. Hello and welcome, I'm your CodeMonkey, and congratulations on going through this entire course. I really hope you learned a lot. I hope you now feel capable of taking the knowledge that you gain here and get started making your own awesome multiplayer games. Like I said, multiplayer games are really all about data. So if you fully understood and learned everything in this course, if so, then you are now capable of making multiplayer games in pretty much any genre. So games like Among Us, Phasmohpobia, Stardew Valley, Minecraft, Lethal Company, Valheim, Overcooked, and many more. The only difference between all those games is really just the data you synchronize. So if you fully understood everything in this course, you definitely should be able to make pretty much all of these games. Now, if you found this course helpful and you can afford it, then go ahead and pick up the premium version. If just a tiny percentage of people pick up that version, I can keep making free courses. And if you do, then now take the time to go through all the quizzes and FAQs to really test your knowledge, to verify that you did indeed learn all this content, all the content in the course. So if you can afford it, that's awesome. But if you can't afford it, that's fine. I hope you truly learned a ton in this free course, and I hope this knowledge helps you on your game dev journey. Just go ahead and hit the like button on the video and subscribe to the channel. It's a tiny thing, but it really does help. Then if you want to continue learning, check out my other courses. My free Kitchen Chaos course is a great beginner course on making a game kind of like Overcooked. That one also has a second course on making it multiplayer. Then my C# course, this one is great for developers of any skill set. It covers everything from the absolute basics, like what is a function, to some advanced topics like multi-threading and asynchronous programming. Or for more game-based courses, my turn-based strategy course, this one is an excellent intermediate course on making a really cool game. Or my dots course, if you want to learn how to write code that runs literally 200 times faster. Or my ultimate Unity overview course, this one covers basically all the tools and features that Unity has. So yep, if you want to continue learning, check those out. Alright, thanks for watching, and I'll see you next time.